Seems to be very nice. And now we are going to have one track for the next 2 days. It's a lot of interesting talks and a lot of new faces and very interesting topics of papers. So be focused. Tonight there will be a demo jam. We didn't want to organize it, but some people have insisted, of course. I insisted. So be prepared. So the only thing you have to know about the demo jam is if you like noise, that's perfect. You know, if you don't like noise, well, not perfect. Just great, not perfect. And so prepare some topics and come forward to see me during the day if you want to register for tonight, right? That's one thing. Second thing, we will be in a different location tonight for the dinner. So the people that used to know how to go there and even come back with different level of alcohol have to reprogram the chipset, right? So it's different location, nice one, and we will give you more detail later, okay? Great, so again, XML Prague is happening because we have a lot of very supportive sponsors that help us, and even then, I think some of them then just shows up and say, hey guys, what's happening? You didn't call us, what's the point of XML Prague this year? Yeah, because it's every 2 years now. And so thank you to the sponsors already, and we have a few of them to come forward and say a few words. Maybe we start by someone you barely know is having they're doing some software, I don't know, with AI and electrons and something like that. I think it's oxygen, or I don't know. Where is the guy I'm looking for? Ah, yeah, he's hiding, of course.
Thank you, Mohammed.
Few words. 2, okay, let's go.
Good morning, and welcome to XML Prague. My name is George Bina. I'm from Oxygen XML Editor. Syncrosoft is the company name. And I'm really happy to be again in Prague for XML Prague. I think I missed only 1 or 2 editions during this time. We have a lot of memories, and we introduced in Prague a lot of, we presented in Prague a lot of new things as we developed in Oxygen. We showcased them in Prague. I hope also you enjoyed the Oxygen users meetup yesterday. In the last many years, we organized an Oxygen users meetup in connection to XML Prague in the pre-conference day. And I hope you will enjoy as much as me all the sessions and all the discussions that we have during the conference. And yeah, have a great time. Thank you.
Thank you. Next, we hear a few words from Pantopics. Please.
Thank you very much. Welcome to the XML Prague. The last time I was here was 8 years ago. I worked 20 years in the field of with XML technologies, and the first script I built was at the university to visualize data series as a pie chart in SVG. It takes a long time, many nights. Since then I do a lot of things. My name is Carsten Becker, I'm from Pantopics. We are a team of knowledge engineers, consultants, XSL developers, and programmers front and back end, and building solutions for our customers that helps them to improve the information processes. In the heart of all processes, we have XSL scripts. They're running in the pipelines, they're running in the services, and bring the information together from different sources, enrich the data and all the things. We how can I say? We work with many systems and technologies. We have semantic technologies, knowledge graphs, and all the things, ERP system, PIM systems, asset managements, and all these systems we bring together for our customers. We wish you a nice day here in Prague. I also have a lot of funny conversations and good ideas that I found here the last year. Enjoyed XML Prague and have fun. Thank you.
Thank you. Thank you very much. Thank you, Carsten. And last for the morning, but not least, is Evolve Binary, which has we have the chance to have not Adam Rater, but Rachel.
Yes, I'm very sorry. I've been masquerading as Adam. I hope that you haven't noticed.
Yeah.
How do
You can use this button, or you can just kick me and I will do it for you.
Okay, that's fine. How about you do it for me?
But you need to kick me.
Yeah.
Slide, or?
Yep, we can move on. So, obviously, I'm not Adam. This is about him. But about me, my name is Rachel Tomasino, and I make it easy for people to do their jobs at Evolve Binary. I manage people, I manage projects, and I fix problems. So, some people call me the fixer, but not in that way, I guess. A little bit about our company. We do consultancy, training, research, and development, and some of the things that we work on. And this is our lovely team, our wonderful team. All work remotely. At the conference, you'll see myself, Alexandra, Alan, and Radek, and please say hello to them. Adam will be presenting tomorrow remotely, so you'll see him, he just won't be here in the flesh. Okay, and so this is about our company, and I think probably you've seen this slide before, or some of you have. Evolve Binary was created as a consultancy vehicle, but now, in the last 4 years, we've grown quite a lot, hired people, taken on clients, so it's been really good. And this is just a little sampling of companies that we've worked with in the past or present, and you may recognize a few of those. Sorry.
Yeah.
Adam, you're missing XML Prague. Where are you? Thank you. Okay, and what's new with us? We have been doing some training. We had, in the past, done consultancy work with training, but we had our very own training program in London in February, and that was a complete XML developer, and we had great feedback. Overall, 4.6 out of 5, 5 stars for the training. And our training courses are really customizable, so if there's something that you need to train your team up on, we can certainly help with that. Just let us know. And, sorry, not done yet. So also, we're still doing a lot of consultancy. We've been working on some unique projects, but still are frequently approached to fix things in XSDB, bugs, and various things. We're hoping to offer those users a better experience when we launch Elemental in Q3 this year. So if you do have any consultancy needs, please let us know. We do still have some bandwidth for that. Thank you. And from Adam, I need to read this.
Yeah,
we deeply care about the software communities and open source efforts that we're involved in. We believe that conferences such as XML Prague are essential to the XML community, and we support as many such conferences as possible. I want to thank the organizers so much for all the hard work that you do. We appreciate you, but we also are so happy to see so many familiar and new faces that come to these conferences. Adam says, there would be no conference at all if you wonderful people did not come along. So, also, Adam is very sad that he can't be here, obviously. He has COVID. And he's especially sad because I think we're sponsoring the bar tonight at the social event. So, yes, wonderful. But please, later on, please join us for a beer and raise a glass. Thank you.
Thank you.
Okay, so thank our dear sponsors again. And now we will start with talks. I'm really glad that this year we have many new speakers which haven't spoken before at XML Prague. So I'm glad that we attracted fresh blood. And the first speaker will be Marta Bartnická, and she will tell us something about how they use AI in creating documentation.
Good morning. I'm Marta Bartnická. I work for Dolby Laboratories, you know, the sound processing company. I am not a sound engineer, unfortunately. I work in a group which is called Publishing Engineering. Publishing Engineering is a group that stands behind documentation team, behind technical writers, and supports them with tools, with process, with everything they need to publish, with everything they need to communicate with engineers, and of course, last not least, to communicate our beautiful documentation to the clients. And why documentation is so important at Dolby? Because, you know, Dolby does not sell speakers. Dolby sells technologies. And for a technology, you basically need to describe it. So at Dolby, documentation is not a part of product. It's basically the product in many cases. Our documentation is authored in DITA, mostly, with an increasing percentage of Markdown. The reason why Markdown is because there is always too few writers. There is always something that needs to be documented by engineers with that amount of technologies to be documented. And engineers contribute also to the documentation. So we actually have a blend of DITA, XML, and Markdown published by different flavors of highly customized DITA OT. And why AI in this picture? Because, well, last year, 2 years ago actually, when AI became a thing, generative AI became a thing, it was an instant thought that maybe it can do something for us, it can help us author, can help us write, and help write also those who are not technical writers and still need to write. And here is a beautiful picture by my colleague, Michał Harytczak, from 2023. When ChatGPT became a thing and GitHub Copilot became a thing, there was initial thought, how can it help us? How can we utilize it? And the answer was that it's not so easy. It's not so easy because, let me see if I can, yes. First, because the public services like ChatGPT know very little about our documentation, which is mostly proprietary and only available to our licensed clients. And secondly, because we don't want to share these resources, code and documentation, with the public engines. We don't really want to throw our valuable documentation onto OpenAI and just give it to them. Same about code and Copilot. So over the next few months, we had to build something that was not just dealing with public systems, but was a bit more proprietary. So what we did is called Stormy AI, and it is both delivering Dolby knowledge to AI as a background, as a context information, and it is secured, so it is built on private system rather than just throwing our data onto public systems. With that, I have to mention that our first pilots were with Oxygen and with AI Positron, but at that time, the level of confidentiality and customization, not because of Oxygen, but because of how OpenAI operates, was just not meeting our expectations. So we built something which we call Stormy AI. That's for 100% internal use as of today, internal use for Dolby employees. And I will demo a little bit of that still. And the recurring question is that, is this system named by Stormy Daniels? Engineers of a certain age always ask me this question, so I have to say no. That was not the idea. The idea was behind another concept called Shitty First Draft. You can Google that. There is a book about writing called Shitty First Draft, which is basically about overcoming writer's block by writing just something and then improving it. It helps many people to get started rather than look at the blank page and just get blocked forever. And because Project Shitty wouldn't probably fly in a corporate environment, we called it Stormy. So Stormy First Draft is the idea that will basically be behind most of my presentation, that AI helps you create some kind of draft and you take it from there. It doesn't do the work for you, it does you the draft, be it whatever draft. So our initial assumptions when we were designing the system was that it will not be just for technical writers, it will be also for support and for engineers, and theoretically we were right. However, I will show you in a moment how these ideas developed. So for writers, of course, create the initial draft, maybe extract terminology, maybe use it to rework the very, very first draft, for instance, to detect inconsistencies or improve the text in some form, which turned out to be a really important use case. For support, to help them react to customer issues, maybe improve the training materials, and maybe expand their technical knowledge by quickly analyzing some existing documentation, which, as I already mentioned, we have really tons of. For engineers was to quickly build documentation because they are not documentalists and they still have to do it, to reuse existing content, which is a bit tricky part because I will mention later that using AI as a search engine is not necessarily the best idea. And basically to figure out how to integrate AI into our existing tools, which sort of is in the process. And here comes a picture which I don't really expect you to look through. The basics is that we are using AWS Bedrock as underlying system with all the AI engines, all the AI models that Amazon currently provides. None of them is OpenAI. It's not because we don't like OpenAI, but just because it happened to be so that Amazon does not support this one. And we are related to AWS infrastructure anyway, so we started from this one. Among the text generating engines, I have to mention Claude, Anthropic Claude, which turns out to be my favorite. There are a few others. We have Llama, we have Mistral, and we have Stable Diffusion for image generation, which is currently not our priority, so we are mostly into text and code. So whatever Amazon can provide, we give to our writers, engineers, support people. And the good part with it is that we are not stuck with one AI model. We can have several just to choose straight in the interface. On top of that, we built the interface, which allows to authenticate our internal users and pass their prompts to the AI system. The users being all types of users, so both engineers and information developers and support people. So as I mentioned, Stormy can do text, images, and code, where main use case remains to be content drafting and content editing. So Stormy first draft idea. Image generation is additional use case which we, as I said, don't explore that much, so we just attached Stable Diffusion as it is and we let people play with it. We will probably explore it a bit more, but for that we would need to improve the training data that we have. But working in text mode is already powerful with diagrams. That's what we learned. And I will get to that in a moment. The third use case is code generation, which we initially didn't think of, but of course, even the generic models can do code very well. However, for that, we have, when it goes to customer-facing code that's going to be licensed, we have a legal clearance in progress, but I will get to that by the end. So let me demo a little bit how the basic usage of Stormy can be like. So here I ask Stormy to rewrite this message user interface message, invalid file, zip file damage, or base ICM file missing. I asked to give me 5 variants that are better English and better understandable for end users. So it gave me 5 variants, which maybe depending on the voice and tone that the UI is supposed to be, I can choose something out of them and figure out something better, because definitely the original message is not very understandable. So that's one of the very good use cases. One of those I call safe use cases, and I will explain that in a moment, why safe. Where you have something written, you know it's not perfect, you know exactly what you want to say, but you just want some ideas how to say it better. But I mentioned that we are not satisfied with base models because we have lots of knowledge that the world doesn't have, that public engines like OpenAI and even Claude or Llama, they couldn't harvest that knowledge because it's not publicly available. It only sits in our resources and it's only provided to our clients. So we took, clean data sources that we have, and we use them as a, not exactly training material, but as a context material for the AIs that we are using. The materials are Dolby Customer, which is a huge customer portal with Dolby documentation, public websites, database of requirements. The requirements are specific, they are short text that define technologies, and the style guide. With the style guide, there will be a funny thing, but that later. So how we operate, we don't retrain really models. We went into what's called RAG, Retrieval Augmented Generation, which is that when user sends their prompt, it first searches, so our system first searches through our data sources and finds documents which are relevant to the prompt, and adds the extracts from those documents as a hidden context. Then the prompt goes to AI with additional context from what we know is true, from what we know is our valid documentation. And then these selected documents go to, along with the prompt, to one of the AI models which are delivered through Bedrock. And then the response is generated, and also users can see those documents that were used as a context. So here is an example which will turn out to be more interesting than I expected. So I asked, actually this is the demo I recorded for a big Dolby event. It turned out really funny, because I asked Stormy for 3 examples of where IMS 3000 is used. It's a cinema system. First, without Dolby sources, it basically couldn't tell much about it. It was not even sure what IMS 3000 is. If I specified Dolby IMS 3000, the public systems would probably know something about it, but not very much. So I asked the same question using our sources, and the result will be totally different, because we'll now search through those sources, find, in this case, top 5 references from each of the sources, and add those as additional context. Different. It will come up in a moment. Yeah. So it gave very nice information so it identifies that it's a cinema system. It provides those references, those reference documents. And you can click on those links. That's our interface. That's not AI anymore. You can click on those references and get to those sources and see the real information, not AI-generated information. You can look at the sources and more of the context. The funny thing about this response is that even though AI was using Claude, in this case version 3, my favorite, was using valid existing data sources, one of the 3 answers is wrong. It's factually incorrect. IMS 3000 NB mode is not used in dual projector setups. And in the room, in this Dolby conference, there were some 30 cinema specialists, and pretty much almost every of them came over to me after this presentation to tell me that, did you notice that the third answer is wrong? And luckily, my next slide was exactly this, that you always have to validate the correctness of generative AI output. So, however, even if we attach true information as a context, it can still generate false results. Even with that, we still find it useful. So this is what we learned from our users. After first alpha phase, we realized that they not only generate text, but for instance, they generate very nice text-based diagrams like Mermaid, Plant UML. They use, very successfully, they use AI for migrating code. In this case, my favorite example is migrating some very complex legacy XSLT into Python that my colleague did. A very good use case is I demonstrate rewriting UI messages or other UX writing, just rewriting to better English, better understandable. Another one, converting engineers' notes into a draft of documentation. So this is basically what we build this system for, and it works perfectly well. And also rewriting an existing draft to follow certain rules. For instance, convert paragraph into bullet points or convert passive voice to active voice. These are the features that are built into Oxygen AI positron. So I have very good experience with this type of usage of AI. All of that, getting syntactically correct data from generative AI, not just ours, from any generative AI, is trivial. So the hard part is getting the right content, but the right factually correct. But getting technically correct data is trivial. So I took this example. I asked Stormy if it's true about if it's sure about the third point, and that's the famous trick with AI that it can sometimes correct itself. So it's confirmed that it was wrong about the third point, and admitted that the third point was not valid. So I asked to rewrite this, the correct part of this response as a data XML reference topic. And you will see that it did it right from just the first try. Actually, I did it yesterday because with AI, you never know if the result on day n+1 will be the same as on day n. And I didn't want you to watch me struggle in that case. But here I was lucky, really in the first prompt, perfectly correct reference data XML document with the right content. So lesson from that is that if our technical writers manage to push AI to generate the right information from the right sources, they can in no time just wrap it in data format and just paste it to Oxygen. And yeah, here I had a predefined reference topic, but as you can see, I got a valid XML topic with no extra effort. So this is our learnings from the first phase. And also in the first phase, we defined what we call safe and unsafe use cases. This is probably the most important slide in what I'm showing. Safe use case is when you know whether a response is factually correct or not. So it's when you're using AI as, there is another expression next to shitty first draft, another expression that I want to promote, stupid digital assistant. So if you're using AI as your stupid digital assistant to do the tedious work for you, but you know what kind of result you expect, then it's a safe use case, because if it does it wrong, you can detect it. Unsafe use case is when you don't really know, when you ask about something you don't know, because then, if you do it for a business purpose, you will still need to check the result in some reputable source or go to an SME. And then phase B, but when we started using data sources widely and started onboarded more users. So it's increasing number of users with little programming experience who successfully generate scripts, for instance, for reworking legacy code. A nice feature was that some users started using Stormy for summarizing Teams meeting transcripts, and they claim it's better than Microsoft Copilot with that. We are proud of Claude, really. Definitely users request more Dolby sources because there is more documentation that I have shown in what we are using, more content that we could attach as this additional, information to search for additional context, and we will do it. In the second half of this year, we will do it. And also users request the capability to have their own, like custom GPTs, okay, to have their own set of documents that they will have as a permanent context. Interesting fact is that only 3% of users want to rate the outputs, and I will say at the end why this is bad, but I have a plan to overcome it. And as I mentioned, generative AI is not a good replacement of search because there is this attitude that people think that if they have a pile of information which is not really well structured, they will just put it into AI and AI will do the search for them. So this is a result of using our style guide as a resource where a person asked, I cannot demo this because I don't really remember where to find this conversation with the AI. But a person asked to check a piece of documentation against our style guide. And instead of specifying what style rules they want checked, they just attached a style guide as a source. And all of a sudden, Stormy has made up a rule that we should use spaces between words in file names. It even made up the number of page where the rule is and the number of the rule itself. Of course, we are not suicidal at engineering, and we don't ask users to put spaces in file names because this always, even though it's 2024, it always backfires somewhere. So definitely it's not what we have in the style guide, it's the opposite. So if you have a style guide, it's probably better to implement a non-AI checker of such rules that can be defined and use generative AI for generating and not for searching against fixed rules. So we have Schematron, we have Veil, we have Term Checker, we are now building VS Code plugin for the fixed rules to prevent people from using AI where it doesn't belong. And coming to the end with what I am to say, as I promised, this consideration about licensing. So what we produce, we generally produce content, code, and stuff because we want to license it. We want to get money for it. We are not doing a lot of, Dolby does marketing material, but it's a small fraction of what we produce. So it is important that whatever we produce, we can license. With AI, it becomes tricky because nowadays it's not clear what the engines were trained on. And both images and code and text can be licensed by somebody, and AI can be just blindly reusing it as it is. So you might turn out infringing somebody's some copyright owner rights, or breaking some open source license, and this is not so straightforward. So with code, we are still waiting legal clearance. For AI-generated images, it's a no-no to put them on the marketing material as they are. For text, it undergoes many checks and edits anyway, but it is important to remember not to just throw it as it is. I hope that Artificial Intelligence Act in Europe will help civilize this a little bit, and similar regulations worldwide, to have training data transparency with proper attribution to content owners, and maybe tagging AI-generated content as well. There will be more about AI and XSLT in the later sessions, so I will just show very tiny little examples of what we are doing. So as we realize that AI, even the baseline models, they are very good with coding, and whatever standard is defined, is widely defined in the internet, AI can do it pretty well. We started using, as I said, we have a pretty complex data OT implementation for our publishing. So I started using Stormy for analyzing and reworking some legacy templates that I failed to even understand after a while, because they are years old and there were a number of people editing them. And also, my colleague has very successfully migrated some of the, not bad, but very complex XSLT that nobody wanted to further develop into Python, which we have more people who want to develop. Also, with other XML processing, well, AIs in general are very good with processing XML because this is a well-defined thing. So you can provide example and say, convert me this into that, and AI will write you a nice piece of code to do it because you can specify exactly what you want. And here is a tiny little example of how we converted. So we had an algorithm to extract from to take term-based extract, which is one XML, and generate out of it. So this is the term-based extract. And we need to generate out of it another XML, which will be used by Oxygen term checker. And I provided some code that we used to take something else out of this term-based extract. And with virtually one prompt, I got a valid code, which gives me the valid term checker file, the file for term checker definition. It then required some tweaking, some adding additional conditions, but it gave me valid stuff at the first try. So this is the type of XML-related work that AIs are really good with, because they like situations when things are well-defined and when you know exactly what you want. And with XML, you always know exactly what you want. And you can provide examples, and you can provide the expected results. So, conclusions so far. Generative AI is helpful, but it's prone to factual errors, and we have to mind the safe and unsafe use cases. So we are not yet ready to build a customer-facing generative AI solution, but we focus on improving AI solution for our internal users. At this moment, nearly 400 and counting. More data sources and custom data sources, also those like custom GPTs. We are into quality checks. We are just starting investigating the automatic metrics, and for that we need human ratings also. Of course, legal clearance for code generation, and explore generating diagrams and images. Thank you very much.
Thank you very much, Marta. I think it raises a lot of questions, such an interesting topic. So, are there any questions? There is a question over there, Mohammed, please.
Thanks for your presentation. It was really great. I'm wondering, you mentioned earlier about the not sending your information to certain providers because you don't want the data leakage, the proprietary information. So do you get that in, I assume you get that in the stack with Amazon Bedrock? It runs your Claude models there? Is that how that works?
Yeah, so Amazon Bedrock is generally our underlying infrastructure, and we have the security guaranteed security, agreements with Amazon. So they provide us, so to speak, walled garden for our Claude implementation, Claude, Llama, Mistral, and all this stuff.
Okay, thank you. One more question.
Hi, Alan Painter. I wanted to ask you about converting from XSLT to Python. You think that's an advance? Because I think in this crowd we would see that as a downgrade. So just wanted to ask you about that.
It depends. I can show you during coffee break, I can show you the XSLT. It is very beautiful but very complex, and we would have no capacity to develop it as quickly as we need to. And all of a sudden, we have a very urgent need to improve our term checkers, different flavors of term checkers, and getting it done in XSLT would take ages. Getting it done in Python is possible. So we just, instead of finding someone who will struggle the XSLT, which was supposed to be me, but I failed, we converted that to Python, and with Python it's kind of easier, and we still get the results. But our major processing for publishing remains XSLT and these beautiful Declarative plugins that we maintain, yes.
Okay, thank you. I suggest that if there are any further questions, they should be resolved during the coffee break, because we have other speakers. But thank you again.
Thank you.
And next speaker will be Octavian. Thank you very much.
Thank you.
I'll take this one as well. Okay, and next speaker is Octavian, and they will tell you something about how they support AI in their products. Thank you.
Thank you, Jika. Hello, everybody. So my name is Octavian Nadolu, and I will speak also about AI. I will change the flavor. So we'll speak about AI for XML development, and what are the advantages and the challenges in using it. So first, a few things about me. So I'm a project manager working for Syncrosoft, the company that develops Oxygen XML editor and the rest of the product. I have more than 20 years experience with XML technologies. I'm also a contributor to different open source projects, speaker from time to time, and co-editor of the Schematron Quick Speak specification together with Nico Kucherauer. So this is the agenda of the presentation. We'll discuss a little bit about what is AI and what AI does, how you can use AI for XML and how you can generate XML and how AI understands XML content. Then we'll discuss how you can generate XSD schemas or XSLT and how you can develop this type of documents, and also how you can automate all these processes using XPath functions. And of course, we'll analyze the advantages and the challenges of using in these parts of your documents. So what is AI? So it's a branch of computer science that deals with the simulation of intelligence behavior in computer. And this idea started from ancient times, so people started to think about using AI in different domains. But in the latest period, it became more and more used in robotics and in other technology. And today, it's used a lot for natural language processing and generative AI. So natural language processing is a subfield of AI that focuses on enabling machine to generate and understand human language. And then we have machine learning that involves training algorithms that learns patterns and uses these patterns in generating content. And we have also deep learning, that it's a type of machine learning that uses neural networks. So today's AI models uses this transformers technology that it's in fact a deep learning model, and it gets an input sequence and you get an output sequence, and then it makes some processing. And it's based of this idea of self-attention that was introduced in 2017 by this paper, Attention is All You Need, by a guy from Google. And then a lot of models started to be developed. So these large language models are using this transformer architecture that are trained on large corpus of data, and there are a lot of models that are developed today. There is this ChatGPT, but there is also BART developed by Google, Bing, Llama, Claude, Mistral, Hugging Face. So there are a lot of large language models that are developed today and are used, and they are trained on different data sets. There are also models that are developed specific on a data set and works better on that information. Others that are generic, like the ChatGPT or the ones from Google and Microsoft. AI for text processing, these models are very good on text summarizations. For example, for generating text, for machine translation, for text classification. So understand very good the text that you have in the document and can generate content based on the prompts that you are giving. For XML, so XML, it's a format that it's readable by both human and machine, and this is a good thing because AI can understand XML, and AI can understand, for example, when you have an XML that defines a person, and then you have a tag with a name, and you have some string there, it will understand that you have the person name in the tag. So understands and knows how to interpret the tags and the information from the tags. So you can generate XML markup, but you can also use AI to translate, let's say, the XML markup to a more human-readable way. So you can use AI to generate XML content, and you can create, for example, an XML content, just an XML document just from a description, but you can also use it to generate an XML content based on a schema. You can provide the schema, and then the AI will understand the structure of the schema, and it will generate the XML content based on the structure that you give. And then you can use it also for known frameworks like DITA, Dogbook, or TI that are already learned. So the AI will already know the schemas. You don't need to provide the schema. You just need to tell that you need to go to generate a document that follows this type of languages. So, for example, you can generate a DITA topic. So you can have a prompt that will say, OK, I want to generate a new DITA XML topic based on the following description. And you can pass a description for the topic. And the AI will know the structure of the topic, so it will know how to generate this XML document. It will start with an ID, then with a topic element, then an ID that contains the name of the description, then a title, and then starts to insert the structure. And I added just a part of the structure that is generated, but it generates more content. So you can have like a draft generated based on a simple instruction, and then you can raffine it and go further and have more information added, or tune your chat to provide more information in order to have the exact content that you want. So you can generate XML structure, and it knows how to generate this based on the information that you provide. You can also have like a generic table generated. For example, if you have some dashes and some content, you can say, OK, based on this, act as an XML developer, then respond with additional information, and then I want to create a table from this content. So it determines that you have some dashes between, so it can create a table. Then it also generates a header trying to explain what the information from each column explains. So it's a feature and description here. But you can also change this later if you want to explain that, for example, this is an action in description. But the idea is that you can generate very easy also on a simple content structure. Then you can use AI to add markup to your content. So for example, you have some documents and you want to add the markup. You can add the markup that is you already used in your document, so you can use your document content to train your AI in order to generate the exact markup that you have in the document. And you can also correct the document to use the markup that you already defined in a schema. So for example, you can have a paragraph that contains some dashes with some lines, and you can have a prompt that will say, okay, act as an XML developer and generate for me a list from this text. So it automatically determines that each line should be a list item and generates for you an unordered list. And I also added here that I don't want additional information, so it will generate only the structure of the list here. Of course, I can provide here more details about the document for which I generate the list. So if I'm in a dogbook or if I'm in the TI, then you can generate a different list. If it's a custom document, then you can provide maybe a schema for that list or other information that you need to provide. Another example is with a table. So you can have a table with missing cells, those with gray, and you can ask AI to add the missing cells from the table. So it will analyze the structure of the table, will check how many cells should be on each row, and then it will generate automatically the entries that are missing in your table. So understands the structure of the table, understands that this should be a table with all the cells added, and then it generates the structure for you. And you can also tell it to have also information in the entries and maybe generate some information there. So AI and XML, so you can use AI to generate XML content. When you generate, the prompt is very important, so you need to pass exactly the information that you want to generate there. And you can get different results from the different models. So if you are using OpenAI, then the prompt maybe doesn't work well on Claude or on other AI models. So you need to maybe adapt the prompt depending on the AI model that you are using, and you need to also check the result. So the prompt is very important, and there are different techniques for creating the prompt. And you need to somehow know how to create this prompt. Some application will help you by providing some prompts, built-in prompts that will help you to generate the content. But the idea is that you can use techniques like adopted persona, where you can say, okay, act as an XML developer, or you can impersonate. You can say, act as a person that knows very well XML and knows XSLT and knows how to develop this type of document. So you can use this technique to create your prompt and make AI understand that you want to generate XSLT or XML content. You need to define exactly the objective. So you create a table from the following content. So you need to define exactly and clear the objective. You can refine the results. So if you ask to generate a table, it will generate a table, but maybe also some information about that table, so like a description or something. Then you can say, okay, I don't want any additional information, I just need the structure. And then you can also provide other context. So you can say, okay, I'm in a table, or I need to generate a table that follows a specific structure, and then provide the structure of that. You can also provide information on requests. There are, for example, OpenAI provides some functions that can be called when you need more information about the action that you provide. So you can say, okay, create me a table, but in case you need more information about the table, you can ask me about the schema and I will give it to you. So you can also have this information provided to AI. You can also provide maybe the location, the XPath location, where you want to insert exactly the content, and it will know better how to generate the content. So the prompt is very important, and how you write the prompt is very important to get the result exactly as you want it. Then you can use AI also for developing. So you can use it for XSLT, XSD, or schematron development, for example, because these are also based on some schema. So AI will know the schemas, will know the structure, and will know how to generate content or understand this type of content. So for example, you can use it to document your code. You can use it to explain the code that you have in your documents. You can use to generate code based on some information that you want. You can use it also to find problems, refactor code, or you can start a conversation about your code. So you can provide the code and then start a conversation and ask it to, I don't know, change, refactor, explain something. And here's an example. So we can say that we have a template and we want to document this code. So you can ask AI to create a documentation for the code and include it as a comment. And this will explain exactly that this is a template and has a match, has a header mode, and then calls another template with a select that is a time resolution. So understands the structure of the XSLT, understand that you have a match, that you have a call template, understands that all the structure of the XSLT, and this is good because then you can use this AI to also maybe change something in your XSLT. So if you ask the AI to change something later, it will know because it knows the structure of the XSLT. Another example with explain code. So you can have like you can have a schematron, and you can have an action that will say, okay, explain this for me, please. And the AI will explain the code for you. So understands that this is a schematron, understands that it's a specific namespace set, that you have a pattern, that you have a rule that defines a context, and the reports that you have there. It explains the reports. So understanding this, it also helps the user that are basic user and they do not know very much about schematron to get more information about what this schema does. But also it helps you to know that AI will understand you when you ask something about this part of the code. So if you want to change something in this schematron and ask the AI, it will know because it knows to explain the code. So then you can use it to generate code. So you can use it to generate schematron, you can use it to generate XSLT, XQuery, or other type of documents. And for example, you can say, okay, I want to create an assert that verifies the number of words to be 10. Of course, it's easy to write for someone that knows schematron, and maybe it speeds up a little bit your work, but for someone that doesn't know to write this rule, it will help you. Then you can create another assert that uses a regular expression, this time an assert that verifies that there is an email in the text. So we can use a regular expression that checks if the text it's an email. And AI is very good on generating regular expressions. So this is hard even for me to write. So yeah, you can Google it, but it can help you to create more easily this. And of course, you need to test them. and have some tests on the answers that you have, but it helps you, and for me, it helps me a lot when someone writes on the support to answer very fast about some rules that a user wants to create. I just ask the AI to create, even if it's not perfect, I can answer easier because it helps me to speed up my work. Another example is with XSD. So you can generate schemas. You can generate schema just starting from a description, like here you can say you want a purchase order, and it will generate a complex type, it will generate the elements, the references between the types, and you can also have more specific prompt that will say, okay, I want to have, let's say, the generated complex type with these elements and refer these elements. So you can be more specific, and you can be more specific and provide also maybe some complex types that already exist in your document and say, okay, reuse this in the generated content. So you can make simple things with AI for developing, but you can also make more complex things, like providing more information for the AI in order to have a better result. And for example, for XSLT, you can provide the current components, like the templates and the function that you have in your document, and allow AI to reuse the XSLT content that you already have in your document. So if you want to generate, for example, a template that performs, I don't know, sorting, and you already have some function that will do this in your document, AI will know that a function does this if you provide this information. So if you said, okay, I have these functions that maybe have a documentation for the function that explains that this function does perform a sorting, then you can reuse this when you are generated content. And you can also provide the associated XML, for example, or the associated schema. And when you generate content also in XSLT, you can say, okay, I want to process the following XML document and do some task on the content. Then the AI will know what type of matches should be made in your XSLT. So you can make it more powerful by providing more information about the context of the refactoring. Then you can also automate these actions. So you can use AI API to automate your actions and perform this more on a set of documents or on an entire document. And a solution for this, of course, you can call the API from everywhere. So a solution for this would be, for example, to create an XSLT function or an XPath extension function. An XSLT function, you can just call the API, but you need to hide somehow information that maybe you don't want to have it in your function, so you need to hide this information. It maybe is better to have like an XPath function that can be used in multiple places. So an example would be to have a function that will verify the content and the function that will transform the content. So you can have a function that will say, okay, I want to verify the following content, and you can pass an instruction to this function and the content that needs to be verified, and then have a built-in prompt that you have in the function that the user will not see and will tell you to respond with true or false. And then you can also have another one that will transform the content, and this time you have a different built-in prompt because you just want to get the transformed content from the function. And for example, you can have the instruction here rephrase to use active voice and the content that you want to transform. And you can use these functions to transform content from XSLT or XQuery, but you can use it also from schematron and SQF. And this is good because you can use it in multiple places. And an example will be, okay, I want to generate some documentation for my functions and templates from an XSLT. You can use this transform content function and say, okay, act as a developer, create a documentation. So you can set a prompt for the transform and generate a content based on the content of the template or function that you want to generate the documentation for. And if you apply this on a style sheet, it will generate the documentation for your style sheet and understands exactly what the style sheet does. It explains here just in a phrase. You can have also a bigger explanation, but you can also have a more simple explanation just to explain what this template does. And you can also make this more nicer. So you can have like an introspection. So you can say a transform content that will also provide like a history of the discussion. So you can ask the AI to generate some content, but you can ask to generate 3 variants, then check the pros and cons from this solution that gives you, and based on this information, generate the content exactly that you want in the output. So you can have a more powerful function that will perform also an introspection of the result. So for XSLT and XQuery, you can perform this refactoring action. You can generate content. You can control the content that is sent through these actions and the content that is modified. And you need to check the cost of the transformation. So if you transform multiple documents, then the cost can be high. And the response sometimes is inaccurate. Then you can use also AI for verifying content, for example. You can check if this phrase contains active voice. And to do this, you just use a rule and assert that uses the verify content function and pass the content of the description. And the AI will tell you that the function doesn't use the active voice. And then you can reformulate, also using AI, to use active voice. And you can do this automatically using a quick fix that will use the transform content function this time, and will transform the content and pass as prompt to reformulate to use active voice. And another example would be with structure. So if you have a list and you want to generate the structure list here, you can use AI to generate this structure also from a quick fix. So you can use this time the transform content function and say, okay, I want to create a data, not the list that with an item from each phrase. And I disable the output escaping here because I want to get the structure inserted in the document, not as text. So you can use AI for schematron and SQF. You can use it to automate your processes. You can use it to correct your content. You control the content that it's sent. This is the power of the schematron and SQF, because you control the content that it's sent and that is modified in your document, and you can automate these processes. The high cost of the validation can be managed maybe if you make a manual validation, or you have a model that it's internal for you, and then the cost is not so big. Also, you need to check the responses from the AI. So as a conclusion, AI is constantly growing, and it's improving more and more, and there are a lot of companies that are developing new and new models. It can be used for generating and for transforming XSLT, XML documents and XML content, understands very well XML document. You can use it for XSLT and XSD, also schematron. You can use these XPath functions, and you can develop your own XPath functions that will allow you to use AI in different parts, so in schematron or in XQuery or in XSLT, and you can perform automatic action. And do not expect AI to do your job, so it will not do your job, but use it to improve your job. There are some resources here, and thank you. I don't know if we have time for questions.
Thank you very much, Octavian, and we certainly have time for one or two questions. So anyone? Oh, over there.
The use case when you receive random XML where there's no documentation about the element names, etc., is that something you have experimented with? Generating descriptions of element names, maybe providing better examples, synonyms, what the abbreviation represents?
I don't know if I got exactly the question, sorry.
So if I get from an external source an XML file with data and there's no documentation about the XML file, could I use AI to help me explain what an element name means, what an abbreviation means? Maybe also tells me they use this name in the XML file, but this is better, you know, that the producer made some mistakes.
Yeah, I think you can use AI, and as I told you can use AI also for with introspection. So you can double check also using AI. So you can ask a question, check the answer, and then use AI to check again if the answer that provided it's better has a better answer for this. So with introspection, you get a better result for this type of questions.
Thanks, and there is a question from Stephen.
So if you can't trust the output, that means you have to check it all. So do you have any idea about how much time it actually saves just producing it yourself compared with letting AI produce it and then having to check it all?
This depends on the output that you want to create. So if you want to create complex style sheets and you are very good on creating style sheets, then maybe it doesn't help you. Maybe it helps you to document your style sheet because you are lazy and you don't want to document your style sheet, so it helps you there. But for someone that doesn't know very well the language, it will help you. It will help and they will learn. Probably they will make mistakes, probably they will not do the perfect style sheet, but I think they will learn faster.
Okay.
Okay.
Okay, thank you very much.
Thank you.
Thank you again. Okay, yeah. Microphone. We'll show you another interesting use case of using AI.
Sorry, one moment, please. I didn't remember. One moment.
Take your time, no worries. I think you have to click on the built-in display and then arrange, maybe. There is extended display. So.
Oh, there we are. Okay. Got a little lost in the windows, kind of like using Zoom, too. There we go. All right, great presentations, by the way, from the former two presenters. I learned a lot this morning already. All right, ready to go. Hi, I'm Dave Gullo, and I'm the founder and inventor of Videate. And we use AI and automation to make software videos that pass the Turing test. Specifically, we use AI and automation to fully interact with applications and devices, and we make compelling videos that don't require any video editing skills or post-production. In order to do that, we need to describe the script. So we have many formats that we deal with. Here would be a Google Doc or a Microsoft Word document, and it's just a 2-column table with narrative and actions. In other contexts, we work with data, and people might use XML processing instructions. Here we have the Videate processing instruction, which calls out a slide that embeds an image. So from these other presentations today, if you're generating content with data, where we pick up is we add decorations for making video. Here's a docbook example. It's another method here with XML comments. You see that in green here. And so we deal with many formats, and as Veet spoke about at XML Prague 2022, we use all kinds of formats on the outside, and then we ingest and validate that on the inside. So I want to show you that a little bit here real quick, and then we'll get into the interactive portion of this. So the net effect of ingestion is to create a Spiel XML doc. That's our parlance here. This is sort of our domain-specific language. And so here we're mousing around and using several UI elements. We're highlighting an element and then clicking another one. Okay, a couple more quick ones just so you get a sense of what we do. In this example, we load a number of URLs into named tabs. We start recording. We focus one, and then we begin speaking while focusing another browser tab, and then we show an image, stop the recording, wait a few seconds, and then resume again. And then the last one is just a zoom test. So here we can control zooming into different quadrants of the screen and mousing around and having it follow it and so forth. So with all of this, I like to say that we're actually more of a transformation company that just happens to make videos, because the stack that we have here is so extensive on the ingest side for dealing with all the various formats that our customers use. So, but I'm not here to sell you on Videate, but rather to tell you about my journey using LLMs to generate XML. But before we begin that tale, I just want to show you a few more rudiments under the hood here that we use, and then we'll build some prompts to work against it. So we're big fans of all the W3C technologies. So as Veet mentioned, let me click that. There we go. Click. There we go. As Veet mentioned, we use Spiel XSD for describing our storyboard and our main parlance. We use XSLT for transforming all forms of documents into XML, because docx, that's XML, data, docbook, many others. And then also, we use XPath all over the place. In fact, where we use XPath is pretty interesting on the UI side of things, because inside the browser is a DOM, and we need to sort of point to things in an evergreen fashion, because the apps that we make videos of, they evolve and they change. It causes a lot of problems, actually. And then we use SSML. So like with SSML, speech synthesis markup language, that's where all of our voices come from our providers, and then we intermix all of these things in mixed content, and that essentially builds the do this and say this forever loop that happens. Okay, so okay, come on now. There we go. While we do use a lot of XML, we do have JSON in our API, which is a better tool for interfacing with our front ends and our front end frameworks. And while JSON schema and JSON path look really interesting, really for our data model, we chose to use W3C sort of XML technologies. So anyways, the biggest benefit to choosing XML over JSON is that it's a direct pass-through to all of these providers. So just real quickly, like if you go to Amazon Poly's website, you'll see the SSML spec. They differ by provider a little bit. And you can put things like break tags and emphasizing words, or dropping into different dialects or languages, and a number of other things. And the same with Microsoft Cognitive Services. Here they have even more of their own MSTTS namespace that allows you to specify just how you want that audio to sound. And the more you can customize it for expression, intonation, phonetic substitution, etc., you're getting more human-like voices, which leads to the videos passing that Turing test. Okay? And so anyways, here's a quick view of our XSD. This is just a sort of day in the life for us. Everything you can do in our system is an element. And here you can see a click tag. It takes a selector, some other optional params, I think. We have other kinds of tags here, like highlight this element, or put a box around it, or give me a top bar, or on-screen titling, et cetera. And then we have things like stop recording, start recording to deal with the flow of control around recording. And here's just a couple other sample elements. Here's your highlight. There it is, your selector param, et cetera. So these are all sort of the ways that we describe various behaviors. This one's really cool. It's a chapter marker. And it tells the output video to essentially stamp it with the chapter. And it makes a thumbnail in VLC or QuickTime Player. And it'll forward reference all the different parts of your video. And even with this, we might do some on-screen effects and explode it into something you see in the video as well. And so it's pretty useful, both for video metadata and on-screen display, et cetera. And then the last one here is like the slide tag. So like we can embed, here you see like access any process contents lack. So we put in well-formed XHTML here, and then we'll show whatever you put there on screen as a slide. So you could build your own whole presentation in our video rendering engine with text and HTML and step through a nice little video. So in a minute, we'll look at some Gen AI prompts and so forth, but I actually want to relay my first sort of initial reactions to using ChatGPT a while ago. I think it's a couple years ago now. And I wanted to use this in my examples today, but they've actually archived the original models for ChatGPT because they're basically obsolete now. But my first impressions from the response was like, wow, because I gave it a prompt, a real simple one, and it came back with well-formed XML right away, the way I wanted it, and I was just blown away. And so I was like, this is amazing. And click, come on now. And so, but also, I had to pause for a minute because it felt like there's some kind of magic going on there, some kind of generalized compute. And I even thought it might spell the impending doom for XSLT, which is heresy, I know, but it was just a wow experience, okay? So, but all comic aside, from this came a lot of expectations, not only with myself, but my partner and my business and many others around what all of this could do for us. And actually, after the presentations this morning, it's amazing to see the applied use of this in Marta's talk there. That was awesome. But anyhow, like this is from Gartner. This is sort of the hype cycle, and it's cool to see the early adopters already using it. But according to this, we're still at the peak of inflated expectations, and really over the next 2 to 5 years, a lot more of this will be practically rolling out, and probably things we're all building here, actually, from what I know. So the magic was pretty strong at first, but also I have a lot of fails, and partly because we have a customized schema here, right? We showed it a little bit ago with that Spiel XSD. And so I learned this morning, watching the other talks, with standard schemas like Ditto or even HTML, that sort of guess the next token thing goes really well, and the confirmation to the schema goes a lot easier than when you bring your own. So, but we'll look at that in a moment. So before we go into the prompt XML journey a little deeper, let's just talk about the simplified stack for generative AI. So, at the top or the bottom, whichever way you look at it, you have hardware vendors, NVIDIA, you have Microsoft and Amazon are, I believe, building their own customized chips to compete with NVIDIA, and so that's a really capital-intensive sort of thing. The second layer, we have foundational models, as discussed already this morning, OpenAI. I don't have a comprehensive list, but that too is very capital-intensive and takes a lot of training data, et cetera. And then sort of in the third layer, there's many in the tooling layer, I just put a few. Think of this as sort of your outer loop to things. I mean, you can have a session with an LLM, and that is in of itself its own loop potentially, but there's other tooling that sort of collates or might call a lot of different systems and bring the response together into something more cohesive. And then lastly, the app layer, where it's going to essentially rely on all of these other layers. And so some of them are black box from some providers because they run up in the cloud and you don't kind of actually know what's running. But I guess that when we're calling these things, we're usually often in layer 2 or 3, basically. And we'll use that as a reference later. So let's explore some prompts and techniques for outputting to XML. Or how to do it wrong. There's a lot of good fails in here that I've sort of tripped across. So yeah, so like here's that example. If it's a common schema, it's going to know what comes next often. And so in this regard, actually, that's why you get a lot of really good, well-formed HTML out of the box, as Octavian actually showed a little bit ago. Bear with me. And so, it's easy to guess the next token, et cetera. So with our case, it's custom XML, so we have to put a lot more into the prompt to name the elements, the attributes, and the namespaces, and we'll look at that shortly. And then sort of the second category of building is like this. This is just some pseudocode or some JavaScript code, and this would be more like the tooling way of doing it. So imagine like an XML builder where the operations in the LLM or your prompt are actually shelling out or actually building the document on the sidelines, and they're using the semantics of what you're saying to actually make function calls versus entirely using transformers. So this is a wild and crazy idea, but I would say this would actually fix some of the issues that I found, at least with some of the things I was doing. For these examples we're going to do today, I'm going to use a tool called Ollama. I don't know if you've checked it out. It's super cool. It allows you to run models right there on your laptop, okay? And the more RAM, the better. And so it's a lot like Docker. So here I said like Ollama pool Mistral, and it looks just like Docker as it downloads. And I believe it even selects models based off of how much RAM you have available. And it will basically pull that down. And when we do these, when we do R&D and stuff in production, we'll use a lot bigger hardware with more RAM, and it ends up being like 80 gigs of a model instead of 4. But for the sake of these demos and this exploration that's going on, it's a really quick way to install it on your laptop, pull down a model, and then run it. And that's what we're going to do today. We're going to run a bunch of attempts at prompts and so forth. Okay. And now for our get on with it moment. Okay, so let's actually do the thing. So all right, make a new XML document with Spiel as the root element, okay? So I asked a bunch of different, I tried a bunch of different methods, and of course ChatGPT gets it, does a really good job. There's our well-formed XML doc. And so did all the prior GPTs as well, but they were obsoleted. This was Llama 2. So we said, Ollama run Llama 2, as you see at the top there. And I asked it just to give me a simple document, and it gave me the Python code. What is that, E-tree? Yeah. Cool, but no thanks. And actually, Llama 3 did a lot better. It actually gave us our blank doc, and we're going to build up on this, so we'll have a whole bunch of these. And then here we asked Mistral, and it made the doc, but then it totally hallucinated a whole bunch of elements. I have no idea why it would do that, but it just needs more direction, right? As Octavian said, you have to change your prompts based off of whichever LLM you're using, and this one just went crazy on us. So here, let's actually do something a little more interesting. Since we're going to be piping this through XSD validation towards the end, we're going to add our namespace because we're going to need that. And so we said, all right, add the namespace. Again, ChatGPT, flying colors. Llama 3, also good. And Mistral actually behaved now. So by adding the namespace, it decided now not to hallucinate. Now, I guess I could up arrow and run this 10 times, and the fact is you get a bunch of different results too. That's part of the challenges section of these presentations and part of truing up and getting a better source of truth here. So it did a better job, great, but I'm still not convinced. Let's keep going. Yeah, so let's do a more practical example, right? So we're gonna make an instructional video about how to set the vacation autoresponder in Gmail, and I'll read you the prompt here in a second. We're gonna give it some instructions that are very compatible with Vidiate's format. Okay, I'll read this for you real quick, really quick. You should not have to read this if you don't want. You are a helpful script writer and summarize technical information into well-spoken verbal scripts for instructional videos. Use a professional and authoritative tone, emphasize clickstream information if it exists, and if you don't put that, you get some stuff. The topic is setting a vacation responder in Gmail, limit the response to 500 words or less. You will only respond in XML, right? And the root element is spiel with an attribute titled XML namespace SSML having a value of the URI, and an attribute titled XML namespace with the value of Vidiate's spiel XST. So in that, we're adding the second namespace we need to be able to pipe this thing through XMLint shortly. For each sentence in the response, add a P element with a child element of that tag right there, which contains text content of the sentence. Okay, so this actually generated a lot of really decent results, and that's what I'm going to go through now. So, well, ChatGPT did a great job. This is, again, version 4, like all of these examples. But what was interesting is that it wanted to already respond with P tags, and we happen to use those too. So here we're doing like a redirection just with the prompt. We're saying for each P element, because that's their thing, add a child element of SSML speak, which contains the text content of the P element. So we're taking the text from one, cutting it, and pasting it into a new child element underneath, which is pretty fun here, you know. You can get into transformations by just defining the differential, if you will. Mistral, I don't know. It just made up all kinds of neat things. And so for me, you know, that's my WTF moment here. It's like, but I've also found when given really good guidance, it can make good XML just from the prompt layer. So, which one was this? Yeah, so actually, this is the first actual well-formed and useful version from Mistral, and all I added different was that yellow stuff. So it's like you do one little thing different, boom, it's finally working and well-formed, but you know, there's a lot of sort of randomness in these outputs, and again, part of the challenges. So now we're going to take all these things and pipe them through validation. So in simplified terms, we're going to take the output of that and pipe it through our XSD and see what we get. So that's why I'm going to sit down and actually use the terminal here. Okay. Okay, so the first thing we're going to look at is, oh, hold on, we need to do this. Yeah, come on now. No. Okay, hold on. Yeah, okay. A lot of tension there. Okay, so, okay, hold on a sec. We're going to zoom that out a little bit. So we have just like a simplified bash script, and the reason we're using this is like to be a little bit tool agnostic. It doesn't matter what language you're running this stuff in. It's just XML and XSD. So, I guess I don't need my. So first of all, we have the prompt, okay, and I don't need to read you that all again. But then down below, we actually run this prompt from the command line with just olama run the model name, and then we provide it the prompt, and then we output to a file, and with the T, we'll be able to see it sort of streaming or whatever. And then the next step is to take that, validate it, and actually we redirect, you can't see here, it's at the end, it wrapped, but we redirect standard error to standard out so that we can just quickly see the errors, if any. And if the exit signal was not 0 on XMLint, we'll put out a fails message, and we'll cat the validation, which has all of the problems with our XML. And then, of course, if it validates, we just get the cool guy symbol. All right, so with that, let's run a few interactively, and then I have a bunch of already saved ones, sort of like pre-baked cookies here, like they're already done, because they do take a little bit of time each time. So I should already be running one here. So we'll run that bash script. There it goes. Cool. So the anticipation is killing me. Okay, so basically what this is doing is outputting, but you can already see that it's putting clicks outside of the SSML block, and that's not part of our schema, right? So great, very good. So I've done a bunch of others of these, so let's just look through them. So that's way too zoomed in. So here's like an example of one that validates, right? And as we saw in some of the other demos, if you up arrow or if you run these things again and again and again and again, you'll get totally different results. So the next one that also validates, I can't do a side-by-side too quickly here, but if you put them side by side, they'd be saying different things and probably a slightly different voice, and you'd get different effects. And so you either need to coach it on the voice you want, and or like with Marta's example, you need subject matter experts to review it or some other systems to adversarially check it or whatever. So these are like the happy path here. That's nice. And in fact, I found that the less complexity in the prompt, the higher degree of validation you end up getting. But like if you start layering on namespaces or some other stuff, you get all kinds of crazy hallucinations. And I'm going to go over those really quickly, rapid fire order. So just to give you some more looks at how fails are coming out, again, clicks in the wrong place here. Okay, that's one style. Another one is, well, sometimes it's like, here's the XML output, and I couldn't find a prompt to tell it not to do that. But again, it's just about knowing the right incantations, and then all of a sudden that thing may get stripped forever. So you really do, this is a sort of glib example, but you want to write your own post-processing, I suppose, before you just parse from standard out, because until you figure out how to only get XML, you're going to get random stuff, only sometimes. Other stuff, yeah, that one's another click in the wrong place, but it does some wacky stuff with quotes occasionally. And this is kind of like if you've ever, well, I'm sure you've worked with XML if you're here, but all the single quote, double quote, and then entities and so forth, it gets that wrong, actually. And so with that, let me actually go back to my deck because it has all the slides of the general fails that I found through this process, and I'll share those. So like, one of them is non-well-formed XML. So, and these were on older models. What's been interesting in this journey is that over the last maybe 18 or 24 months, the models have gotten better and better and better, and they've stopped doing bad behaviors, okay? But you'll still get that from some of them. Probably not if they're using a builder method, though, behind the scenes using a real DOM, because you couldn't do that if you were. But hallucinated namespaces, I've had crazy stuff show up, and that can break validation in some cases, depending on how it hallucinated it. Bogus entities. I mean, surely we could be more resilient and import namespaces and so forth, or DTDs or whatever that is needed to correct for that, but sometimes you'll get even more wacky entities that are on the fringe. Unintended preamble or like head content, yeah, that can be just solved with processing it a little more defensively. And then stuff like, this is the quote thing I'm talking about. I'll leave that up for a second. It's hard to make sense of all of that, especially at the end here. But so I'm sure with sort of honing the prompt, you might be able to get better and better at this, but sometimes when I tell it, don't do that bad thing you're doing, it doesn't necessarily do any better, actually. So a couple other ones here. Arbitrary element hierarchies, and in fact, I think, yeah, in this one, this is an example of that came up while I was running samples for this talk. So like, maybe literally 1 in 50 to 1 in 100 attempts, it just does that. So here it forgot to put a terminating p tag, and it pushed a new child, and now you got 2 nested p's. Okay. So in closing, it seems like in general, when you're using like ChatGPT, the engines that are a little bit more opaque, they do a better job and utilize XML Builder. I actually was impressed this morning with seeing how other models are using data with better, and HTML with better efficacy. But at least with custom schemas, I'm still on this journey to find out better and better ways to do this, and I hope to learn from all of you today and this weekend. But yeah, people don't want to send their proprietary data into the cloud, so like you're going to basically be running your own models or signing an agreement with the provider that's going to let you have that data security. Yeah, so look, as these tools evolve, I hope to get the net effect of as if they were building a little DOM object on the side, but it's looking like these transformers are just way better trained on already known schemas. So I believe in my journey, I'm looking for something that's going to actually be able to let me say, all right, use this XSD, now go build me something. And at every step when it's assessing, adding things, and it might have a sort of tendency to want to hallucinate something or add garbage to the equation, I'd like it to self-check itself even before outputting. When we were doing a lot of R&D with this in the last 6 or so months, what we ended up just doing was running it again and again and again and again, and if it was exiting not a signal exit code of 0, we just do it again and do it again. And so it's like we end up finding ourselves just sort of brute forcing it, but I believe there's probably more efficient ways further up the chain to do this. So after all of that, with all those fails and so forth, I'd like to conclude with, I would like to rename this presentation An Idiot's Guide to Failing at Generating XML from LLMs. So based off of all those random things. So with that, I appreciate your time. Thank you very much.
Thank you very much, Dave. And we have time for questions. So anyone? Yeah, from Marta.
About how different LLMs behave with XML stuff. My first experience with XSLT and ChatGPT, even GPT-4, was that when I put some really complex template and asked for improving it, like it's doing this and I wanted to do that, ChatGPT would tell me, you probably need to check that and you might consider this, but wouldn't give me the code no matter how I tried. It would just give me plenty of advice, but never code.
Yeah.
So Llama, yes, and Claude, yes. Claude doesn't care of getting dirty and just doing some templating. Sometimes wrong, but at least it tries.
Wow.
What's your experience with ChatGPT? Did it ever do these things to you, to just give you advice instead of giving you code?
No, but actually ChatGPT from the beginning, like my first prompt ever was, all right, take the first 10 sentences of the US Constitution. It's a very well-known document, I guess, and chunk it out like this, right? And it put it into our parlance, and I picked that up, dropped it into our engine, and I made like a, 2-minute video out of that. And that was just first shot ever. And so that's what led to sort of that hype curve enthusiasm. But along the way, we would use it also to generate reference or test material, et cetera. And it had always been good about it. But when you want to get into complex things is where it gets tough, especially putting elements in mixed content. Yeah.
Okay, thank you. And one last question before coffee break from Stephen.
So let me ask the same question I asked last time. Does it save you any time?
Well, actually, me, no, because I write that XML from memory. Me personally, no, but that's an open question because our customers are subject matter experts already and they're tech writers. Yeah, so then it comes down to just the bootstrapping, sort of like an outline or a reference version that then gets a little bit more continued. So it does help break that writer's block barrier. But I'd say the jury's out on that. We don't have enough data from our own customers to say, yeah, we'd rather generate this from whole cloth rather than to write it ourselves.
Okay, so thank you very much again. And there is coffee break ready outside, so you have 20 minutes to enjoy coffee and some snacks, and also to speak to sponsors in the coffee break area. So see you there in 20 minutes.
Thank you. I appreciate it. Thank you. Hopefully that was
Yes, yes, of course.
Maybe you have to start, and you can put this into your pocket.
I haven't got a shirt pocket, which is silly. Oh, my Mondo.
Escape and restart.
What happened there?
Yeah, because when I plugged, I think it was not the same dimension. I think you have to escape and restart the sharing, so you can get the right dimension. Just yes, something like that.
Cool. Okay, and it's my pleasure to welcome Mike A. I think maybe you have been speaking on all XML Pragues in past?
I'm surely not all, but quite a lot.
Yeah, okay.
But never mind that. Welcome to those of you who don't know me. My name is Michael Kay. I work for Saxonica. I set up Saxonica 20 years ago. It's now, we didn't achieve my objectives, which was to keep it to a 1 or 2 person company. So it's grown a bit bigger than that, but not too big. So it's still quite small and compact. And we'll introduce ourselves in the sponsor presentation tomorrow, I guess. The talk today is a mixture of a sort of Saxonica talk and a personal talk and a Qt4 working group talk. It's a personal perspective on an aspect of the work that we're doing, creating 4.0 specifications, 4.0 versions of XSLT, XQuery, and XPath, with very much a focus on the things that we're doing related to processing maps and arrays, which means, in practice, processing JSON. So let's give you a little bit of background on that. The 3.0 specs, which came out in 2017, don't we have fun when time flies? So they introduced maps and arrays as data types, rather more thoroughly in XQuery than in XSLT, because XSLT was designed to work with XPath 3.0, which didn't yet have arrays in. So the support for arrays in XSLT 3 was a little bit incomplete. But in fact, it was all a little bit incomplete. And that's why I say many gaps in the functionality. I gave a talk in XML Prague in 2016. Again, seems an enormously long time ago. And in that talk, I explored some use cases of processing maps and arrays and JSON structures using XSLT3 and in preparing that talk, discovered and presented some of the gaps in the functionality and how some things were actually quite difficult to achieve. And those use cases have motivated some of the work that we've been doing in the 4.0 specs to try and make some of those basic operations rather easier. And so part of the purpose of this talk is to show you what progress we've made in solving some of those use cases. A reminder, though, of why we introduced maps and arrays. There were probably sort of three strands to it. It started with the fact that XSLT 3.0 had a major objective of supporting streaming. Streaming means that you produce the output as you're processing the input, so you don't have to read all the input until you before you can start producing any output. That means you need some kind of memory, because typically you need to remember what's happened earlier in the document, and that memory has to be flexible in its data structures, and it has to be efficiently updatable. And so we introduced, but efficiently updatable within a functional, within the context of a functional language where state is immutable. So you have to produce new maps efficiently from old maps, but as an incremental change. And so maps were the data structure that we added to the language to support streaming. And then we realized if we do maps for streaming, we can also, we've got half the work that we need to support JSON, because during the process of developing XSLT3, JSON was becoming a lot more important. And so there was well-developed support for maps in XSLT3 in the beginnings of support for arrays, which are the two data structures that the JSON supported that XML didn't provide us with. So we got quite a long way with 3.0, and maps and arrays in 3.0 are extremely useful. But when you come to operations on trees of maps and arrays, such as you get when doing full-scale JSON transformations, you find there are gaps, and some of those gaps we're trying to fill. That's part of the Qt4 project. Again, a couple of years ago here in this room, I introduced a project for starting 4.0 specifications. That project took a while to get underway, partly because of COVID and things, but partly because I'm not very good at starting projects. So Norm took over project managing it, and it rapidly gained acceleration when he started managing it, and I focused on the technical side. That project is doing a lot of things. We've made I think about 500 individual PRs to the specs, changing sometimes very, very minor details, sometimes fixing bugs in 3.0, some major new features, and I'm just focusing on a small number of them. The things I'm talking about today aren't necessarily stable in those specs yet. They aren't necessarily even in the baseline spec. I think there's a reasonable amount of consensus on, sort of 95% level consensus that we're going to have something like this, but it could still change before we put it in. I'm going to show you some things that are implemented. The paper also talks about some things that aren't implemented. So we're very much talking a snapshot of the current state of play, which will change before we get to final specs. 3 points I cover in the paper. Firstly, navigation. How do you navigate trees of maps and arrays? In other words, navigate JSON structures. But remembering that the XSLT model, the XQuery model for maps and arrays is more general than the JSON model. It's not just JSON, because you can have, for example, have maps that contain nodes. You can have maps that contain sequences, and so the data model is rather more orthogonal in terms of mixing bits of XML concepts with bits of JSON concepts into a single unified data model. So it's a generalization of both the XML model and the JSON data model. So navigation, and then what I call point update. You might think of it as in situ update, but in situ update implies mutability. But by point update, what I mean is small changes to large data structures within the context of a functional model where what you get from an update is a new version of the structure. And one of the key things one wants to achieve there is the kind of benefits that you get with functional data structures, where making a small change to a large structure is cheap. It's proportional to the size of the change rather than proportional to the size of the data you started with. One of the problems with doing XML-based transformations, if you want to do something like something we've also published papers about, how to write an XSLT compiler in XSLT, you find you're doing 5 phases of transformation, and some of those phases are doing very small changes to the structure, but making a small change to a structure with XML means copying the whole thing over. And the reason for that is things like node identity and parent pointers. You don't have node identity and parent pointers with maps and arrays. That gives you a different set of problems. You want to retain the benefits of doing efficient, constant time updates, and to eliminate the problems that gives you of not being able to navigate upwards in trees. So that's part of the theme of what I'm talking about here. Then the third item is bulk transformation, by which I mean recursive descent transformation in the traditional XSLT style. And I talk about that in the paper, but I'm not going to talk about it here in the talk this morning because I decided well, for 2 reasons. One is I decided I hadn't got time, and the other is that there's actually a bit of a disconnect between what I think is going to appear in the specs and what's currently implemented in Saxon. So I felt I couldn't demonstrate what I thought was the final result would be, and therefore it would only be confusing to demonstrate anything. So the paper gives you a snapshot as to what I think the spec will be like, and in Saxon we've got a variant of that we've improved on in the specs since. But I will talk about, also under bulk transformation, as well as the recursive descent transformation, I also include things like grouping and inversion and sorting, and I'll talk about a use case in that area, both from an XQuery solution and an XSLT solution. So navigation, there are basically 3 things we've done. We've added the double question mark operator, the query operator, as an analog of the / operator for navigating XML trees. We've got the ability to select items by type, and perhaps architecturally most significant, the ability to navigate upwards as well as down. So I'm going to sit down because I can't type standing up. I've learned from experience that the effect is somewhat comical. And I'm going to illustrate some of the navigational capabilities in Saxon's Gizmo tool. So I'm running Saxon's Gizmo tool from the command line here. Oh, it worked, hooray. A reminder what Gizmo does, it gives you it's an interactive XPath evaluator. So I can show 2 + 2, and it gives you the result, and I can show 1 to 5, .*2, and it gives you 2, 4, 6, 8, 10. So it evaluates XPath expressions interactively. And so I'm going to set a variable to an input document, and the document I'm going to load is it's a document that comes from the JSON path specification, which Alan Painter is going to talk about in the next talk, but I don't know if he's going to use that specimen document, but this is the one used for examples in the spec itself. Whoops. Did I misspell it? Yes, I left out the JSON. So if we show the contents of that variable, I'm not sure how much will show on the screen on this size. Not very much. So it's a ridiculous document, comical document. It's totally absurd, but it's illustrative of the fact that we often have to work with comical documents in real life. So it's not realistic as you might be a badly designed document, but it's not totally untypical. So we've got a store with 1 bicycle and 4 books, which possibly is a little unrealistic, but it does help that they fit on the screen. Now what we can do in the 3.1 spec already is to do something like show $in store. Can I spell bicycle? On a good day, I can. So the question mark operator is the analog slash. When you're navigating XML, it just goes down one level. But one should note immediately that the names here fulfill a rather different role from the names in XML. Your microphone stopped working. Okay.
So if you can maybe keep it here.
Okay. Thank you. Is that better? Yeah. So the names in JSON fulfill a different role from the names in XML. In fact, names in XML fulfill 2 roles. Sometimes they're naming the kind of object you've got, like this thing we can see here would be called a book. In JSON, it hasn't got a name. The properties of the book have names, and those are a bit more like attribute names in XML, or you might use XML names for the properties and name the properties. But the other thing is that they name the object type. So element names are sometimes types of thing, and they are sometimes the relationship of that type of thing to the parent kind of thing. So the names have a different role, and in particular the books here are unnamed, except that we've named the set of books book, which is confusing. So this document has an array of anonymous objects, and the array of anonymous objects is called book rather than books. So bear that in mind. One thing we've added, the simplest thing we've added is that you can now abbreviate that to show $in / bicycle, and it bypasses the immediate stage. Let's remind ourselves why that's useful. It's useful for a number of reasons. One is that the path might be very complex, and it's hard to get it right, and it's just noise, and so it's an abbreviation capability. You don't have to put in the detail you don't need. Another is that the path might differ between different bicycles, so you might have different bicycles at different places in the structure, and this finds them all regardless where they are. I know I give a third reason in the paper, but I can't remember what it is now. So that's the first thing we can do. We can go straight down, and of course we can also go further down from there. We can find the prices of the bicycles like that. Now there's here a difference between XML and the JSON model. If we do this, we've got 5 prices there. We've got one is the price of a bicycle, and the other 4 are prices of books. From those numbers, if it was XML, we'd be able to navigate from those results and find out which price was which. We'd be able to ask what's the parent of this price? What kind of thing is this the price of? With a pure JSON model, we don't have any upwards navigation, Therefore, you've just got a set of 5 numbers here. You can only manipulate them as 5 numbers. You can find the average, you can find the max, but you can't say, are bicycles more expensive than books? But I'll show how we've tried to solve that problem. Some of the other things you can do with this, of course, you can find the average by pumping that into a function. Again, the arrow operator is there in 3.1, and it can be used in this context, so the facilities work together. Then the next thing we've done is that you can talk about types. You can select a bit more selectively. So to illustrate that, we can select all the things that are of type record, title, author, star. The books, remember, don't have a name in JSON. We can't ask for individual book elements because these objects are anonymous, they're unnamed. So instead of using the name of the object to find them, what we can do is we can find them by structure. We've introduced the new data type, record, title, author, star. That's matched by any map that contains a title and an author and optionally anything else. So anything that matches that pattern of having a title and an author and possibly other things will be selected by this predicate, which is, if you like, a substitute for being able to call that a book. We haven't got a name for it. We could actually, not showing this here, but we could give that structure a name and just say, find me the things of type book. But that's just a macro for saying, I'm going to call anything that's got a title and or an author, I'm going to call it a book. So it's duck typing. If it's got a title and an author, it must be a book. And of course, we can then combine that with other things as well. So if we want to only get parts, if we don't want the author, price, ISBN, category, and title, but only want a couple of the fields, we could filter the maps that we get out and say we're going to select the ones that FN of key is a shorthand in 4.0 for function of key, and we're going to select those that, will you be able to read this when it goes off the screen, hopefully? Author, title, I've got that wrong. Yell at me when you see a spelling mistake. I've got to close that, and I've got to close that. So it hasn't, yes, right. I did that mistake before, and I've forgot how I corrected it. Yep, I used the wrong arrow operator. The reason is I've got a set of maps on the left. I want to apply that map filter function to each one of them, not just to the set of them as a whole. So we've got a new operator in 4.0 that says, apply the function to every item in the sequence, which is this wonderful equals bang arrow operator. And that then gives me a set of 4 maps, which is the result of filtering the original map to only select some of the fields of them. I can also apply a mapping function to each of those. So, for example, I've there got my set of 4 maps, and I'm now going to process each one of them by creating a new map. You're used to writing map, the map keyword followed by curly braces to create a map constructor. The map keyword is now optional. You can just use bare braces to construct a map as in JSON itself or as in JavaScript. So I can create a new map that contains the author and the title, like that. And that is just another way of creating maps that contain a selection of the fields. And of course, I can use that type syntax to not just to select maps, but I could, rather than selecting all the prices, I could say, give me everything of type XS double, if that was a useful thing to do, and it gives me all the numeric values in the data and so on. So I've got a lot more flexibility now in how I process and filter the data. Let's look a little bit more at how we do the upwards navigation. So when I talked here last about the problem of parent pointers in JSON and how to do upwards navigation, I presented a model for it in which we don't add node identity and parent pointers to the data, but we remember how we navigated downwards so that we can retrace our path and come back to and follow not the intrinsic parent or owner of the data, but ask a question, how did we get to this data? So we annotate the results of this path expression, this query-based path expression, with not just the values that we found going downwards, but the path by which we found them. So there's additional annotations on the result, labels on the result, saying how did we get here, and knowing how we got here enables us to go back. So if I do, so basically I can qualify the question mark now by saying rather than just the values, I want the entries that we've found. And if I do that, then we found that what we found is not the strings, but we found a selection of records that contain a key, which is sometimes ISBN, sometimes category, sometimes title. So I can find all the string-valued things with the name of the property that was selected, the actual value of the property, and then we see I've got some functions available as well, which enable me to go back upwards through the tree. And to show how that can be used, I can show. I'll do the prices this time. No, I need entry price. And then I'll select the ones that are the prices of something that has an ISBN. So I've now only got 2 items selected. I've still got the full entry details, but this time I've selected the ones that, by filtering upwards, looking upwards at the parent and saying, is this parent an object that has an ISBN? And of course I can then say I actually want to display the price by showing its value, which gives me the actual values. So I've got some intermediate data that gives me extra navigation capability. How are we doing on time? I'll skip from there to talk about updates. Whoops. So the first use case that I did in 2016 that showed this was difficult was to take a fairly similar kind of JSON data set and say, how do we increase the price of all products with a particular keyword by 10%? And I explored various ways of doing that, and there are the 7 pages of the paper from 2016 that describe the solution. I found, in fact, the easiest way of doing it was to translate the data to XML, do the query in XML, and then convert the XML back to JSON, which is incredibly long-winded, but it was the best I did it directly, and the reason it's 7 pages is that there are actually 2 solutions there. But the easiest solution is to convert it to XML, do the transformation, and then back again. I thought I had another slide there, but not so. The solution here, in the 4.0 spec, I need to load a different document. Let's just show you the basic syntax of update. So there's a new update expression, which might not have exactly this syntax. We're still playing with it. So we've got an array there. We'll select the second item, and we'll replace its value with 10. Whoops. I've got to say update array. And it gives the updated array. Now, of course, there are simpler ways of doing that, but when you get to deep update, it becomes more interesting. Now, hopefully, the syntax of that update expression is very, very easy and intuitive to understand. The semantics of it are actually extremely complex. Because to make that update work and return not just the updated value, but the updated array, you've got to consider the fact that a number of things might have changed. You've got to consolidate those updates. You've got to propagate them upwards back to the root of the tree of the maps and arrays, and then return an updated version of that contains all the individually updated leaves. And to do that, you've got to use the same kind of technique of tracking how you got down to the leaves that you've updated. You've then got to track back upwards, find when you've made 2 updates to the same container, apply all those updates to the container, then propagate them upwards again. In fact, the current spec isn't defined that way. The current spec is defined in terms of a top-down recursive descent transformation, but the implementation works bottom-up in that way. It's actually been in Saxon for a while, but with different syntax. Hopefully the new syntax is much clearer and more intuitive. So that's the basics of how update work. And if I do an example of that, I'm short of time inevitably. But let's load another JSON document. And we'll show you that document, which is the same one as I used in 2016, where we've got a number of prices of things. And I can then bind another variable out to the result of an update. It's an array of products, so I'm going to replace some of them. I'm again going to select by type, and I'm going to select things that have tags and prices. And I'm going to select the ones that have ice among the tags, because that's what the query said. I don't know why it did, but so I'm updating selected prices, and I'm multiplying them by 1.1 to give a 10% increase in those prices. It's done that query, and if we show the result, then you obviously memorized the price, and it wasn't 1.375 dot that. So it's updated those prices. It's updated that price, and it hasn't updated the second one. So that's done what was needed. So that was the first use case. So it's now down to a single line command from that 7 pages of text. The second use case that I tackled was given a list of courses with the students on each course. How can we build a list that contains all the students with the courses that they attend. So that's a classic hierarchic inversion kind of query, a grouping query. I won't type this one in, I could, but I'll just show you the result on the screen. It's a bit too much typing to do. But the XQuery solution to this now is that we construct an array for every email at any depth in the original structure. We group it by the value of the email. We order it by the grouping key, and then we return a map that contains the email address and the set of courses. And to find the set of courses, we have to go upwards to the ancestors. So remembering those aren't ancestors intrinsic to the data, they're the ancestors in the sense that this is the route by which we found the data on the way down. We're retracing the steps upwards to find the course that each student belongs to. That's the XQuery version. The XSLT version is extremely similar. So it does grouping. It selects the courses. It groups them by the entry email. It sorts by the current grouping key. Then constructs a map containing the email addresses and an array of the courses, again using the ancestor axis. So I think that's probably where I will stop. I'm not going to talk about templates over maps and arrays because I haven't got time, but there's a lot of material in the paper which I encourage you to look at if you're interested. Let's take questions there.
So we can take questions, or you can continue for 5 or 10 more minutes because we started later, so it's not your fault. It's
great.
So, question from Stephen.
So, from a syntactic point of view, is there a particular reason why you have to use the parent function rather than, let's say, /...
Slash has all sorts of semantic baggage with it. Probably could have made it question mark ... There is a reason for making it a function. The reason for making it a function is to avoid getting into the position where maps are cyclic, where maps contain references to themselves. Because without identity, that would make the recursive expansion of the map infinite. And so we've avoided that by making sure that the owner information is only accessible via a function. And that prevents that infinite explosion.
Okay, thank you. Some other question? From John Snelson.
So, I already held this opinion, but adding more syntax that's specific to maps and arrays just highlights the fact that really we're designing a different language to work with JSON and arrays. It's not XPath, really.
Yeah.
And I just wondered what your thoughts on that were. I kind of regret the direction that XQuery went in, and I would much rather have struggled to come up with a good XPath syntax that also worked over them.
Yeah, I mean, we've got a hybrid data model that's in some ways, it's a blend of XML and JSON and not a unification of XML and JSON. And that's reflected in the fact that the language is a blend of different capabilities addressing different parts of the data model rather than a unification and integration. The data models are sufficiently different that I think that's almost inevitable given what we're trying to do. I don't see I recognize the problem and I don't see an easy solution to it. It does derive from the fact that the data model itself is lacks the kind of orthogonality that one would ideally like. And part of that is, that, I mean, I start the paper by saying XML trees always have owner pointers. JSON trees never have owner pointers. There's nothing intrinsic to the syntax of XML or JSON that says the tree models should be so different. But yet that's part of the culture, part of the background, is that with XML we expect to be able to navigate upwards. I speculate that the reason why it's required with XML is that it's needed, particularly with recursive data structures. XML is focused on text, text is recursive, therefore the needs of text processing generate a need for parent navigation, which doesn't exist in the data world. So you are blending cultures and force-fitting them together in a way that where there's no grand unified theory of things.
Okay, thank you. Some other question? Do you see someone, Mohammed? Okay, so thank you very much again then.
Okay, thank you.
Disconnected before it falls. Thank you very much. And before we will switch speakers, I will just remind you that Mike mentioned his paper in Proceedings, and Proceedings are already available for you. If you will just go to the conference home site, there is a link to Proceedings in PDF. So if you would like to study this topic in more detail, you can read Mike's paper. XPath and navigation.
All right.
And JSON.
So I'm Alan Painter. I work for HSB. Before I used to work for HSBC France. They changed their name to HSBC Continental Europe. I grew up in Texas, and I moved from the United States to France about 30 years ago. In 30 years, I've gotten to learn a little bit of French. And one of the things that I've learned the most about in learning French is I've learned something about English. So a lot of things about English. And I think in some ways we can learn, by studying JSON-Path, we can learn some things about XPath with respect to handling JSON. Now, obviously Michael Kay has just shown us the future, and it's going to make things much simpler. And there's a couple of spots where you'll be able to fill in the things that I've left sort of blank with some of the new information that Michael Kay has shown us. And I'm very excited to be able to use that in the near future. I hope it's in the near future. So I've used JSON-Path for about 10 years within a testing framework for APIs. And you see that quite a bit. I was just curious, how many people here have used JSON-Path? Show of hands. See a few. Okay. Just want to talk about JSON-Path for a second. Let's see, is it that one? All right, so JSON-Path first was proposed in 2007 by Stefan Gössner in a paper on the internet. He said that XML has excellent tools for handling extraction of data. And so we need something for JSON as well. So he proposed XPath for JSON, JSON-Path. So that's where it started. There's a site in GitHub that's written by Christoph Bergmer, and it is a comparison of the 50 different implementations of JSON-Path in 20 different languages. This was used as part of the run-up to the new standard. Here we're seeing that there's about 200 different JSON-Path queries with the results compared from all of these different implementations. And so we can sort of see that we're just trying to determine what is the consensus. So we can see an X here for, well, this one's not in the consensus and this one is. all we see here's, we've got a downward arrow to show, well, this one is not in the tendency, this one is in the tendency, but there's not a clear consensus either. There's also some errors. There's a lot of divergence in the results here. So that was part of the reason that the standard came up. So JSON-Path is also very widely adopted. You see it in Kubernetes, the very popular container orchestration tool. You see it in Amazon Web Services as part of their serverless offering with step functions. The Google Compute Platform, also known as Google Cloud, in their Apigee, so that's for their API management mechanism. You can see that we've got, they do have XPath, but it's for XML, and then we've got some JSON-Path, it's for JSON. So there's sort of this idea that XPath doesn't work for JSON here. And so this year, February 2024, but it's been going on for a couple of years, there's a working group at the IETF, the International Engineering Task Force. They came out with a new proposed standard, 9535. If you go into YouTube, you can see that the IETF, they have a channel. If you query JSON-Path on the channel, you find there's more than 20 videos. So they've had about 20 working group meetings. There's a couple of hours of video for each meeting. It's fascinating to watch. So I've watched about 10 minutes of it. So they have documented all of their working group. And there's a new Wikipedia page. Now, it's a little interesting because JSON-Path has been around for a long time. Wikipedia, if a thing is a thing, it's in Wikipedia, but it's just shown up this year. So there's been a lot of effort for JSON-Path this year. And what I wanted to do is bring this in and show some commonality with the creation of XML. And so one of the things I've done here is I've highlighted Tim Bray's name because he appears, of course, in the XML 1.1 and the 1.0 recommendations of the W3C. But he also appears in the JSON, the IETF JSON data interchange specifications. So this is following on of Crockford's definition of JSON, which was not a proposed standard, but was just information about the media type. And so in 2017, RFC 8259 became a standard. And that is an internet standard. There's 99 internet standards. There's about 10,000 RFCs. There's 99 standards. There's things like Tim Berners-Lee's URI, that's a standard. HTTP is a standard. TCP is a standard. This one is an internet standard. And then this year, a new proposed standard for JSON-Path. So one of the things that I noticed is that JSON-Path appears in 2024. XPath 1 is 1999, so there's been a quarter of a century between the two. I think that's a long time, even for standards. So let's take just a quick look at JSON. In the standard 90, 7 different types of data. The 2 that are structured, objects and arrays. We've got numbers, strings, those are the primitives that are variable, and then we've got 3 literals, including null, true, false. The standard tells you null doesn't mean anything. It doesn't mean something's absent. There's no semantics behind it, so it's a very simple standard. That's maybe one of the reasons why it's been accepted. It's simple enough to where everyone agrees to it. Okay, RFC 9535, that's the new JSON-Path proposed standard, has a very simple objective. It says we're extracting values from within a given JSON value. So we're not trying to create an expression language that can do everything. We're not trying to recreate XPath. We're trying to create something very simple for extracting given values from a current JSON value. So let's take a look at that. They defined the execution environment. This is a bit simpler than the XPath execution environment, where there's no in-context namespaces, variables, and there's simply a single query argument. So this is some JSON value, some arbitrary JSON value. There's just one of them. And then we've got this query expression, and that's the JSON-Path expression. And we're going to produce an output node list of JSON values. So it's a node list. That's not part of JSON. It's kind of like sequences. It's a list of things, but they're not an array or something else that you can recognized in JSON. And then we've got the location of it. This sounds very similar to what Michael Kay was talking about. So it says that it's always a pair. We've got the value, and they're also saying, well, where is that value in the query argument? And this is a unique, it's normalized, they call it a normalized path. It tells you exactly where that value was in the query argument. Okay, so let's talk a little bit more about the query expression. JSON path says that there's three things in JSON path. There's identifiers, segments, and selectors. So those are pretty easy. The identifiers, the dollar is just sort of like the source document to an XSLT transformation. The dollar says this is the entire query argument. This is the root of the query argument. Okay, and there's one other identifier which is only usable within something that looks like an XPath predicate. So it's for the context node when we're working with a list of input predicates and we're using the filter expression for it. So we'll take a look at that. So segments, this tells us how we're going to traverse the tree of the JSON argument. Either we're going to, so a selector, the canonical selector always has the square brackets around it. For the descendant, it has two dots in front of it. So you can either choose children or you can choose descendants. And Stefan Gester says it is based upon the XPath path operator with a single or a double slash. So you can see that in this case, this is an array, so we're choosing the two children. Let's say that the segment presents the two children to the selectors, and maybe those selectors will select them. Or the descendant segment is going to present all of the or all of the descendant elements. Okay, and maybe the selector will select those. One of the things that you cannot select the keys in JSON path. That's not a valid JSON value. You can select the whole map that contains all of the entries, but you cannot select those keys. All right, and so JSON path looks then like it always starts off with the dollar. It has to be the first character, no spaces before. Then we have a series of selectors. Here we're seeing them canonically. There's also a shorthand. And it says that, so after the first selector, segment, could select the first two, these two children. The second one then could select at a lower depth. The third segment could go all the way to depth 3. Depth 3 has no children because it's a primitive. And so this fourth selector necessarily can't select anything. So you're always selecting downwards. So within those segments, you can have a list of selectors. There's at least one. And there's 5 kinds of selectors, and I think these are mostly pretty obvious. The name selector is going to be for choosing the value associated with a key within a map. In the XPath world, they call that a member name with a member value. In the JSON path world, wildcards, we're going to choose all of the members of an array or all the members of the member values of an object. So once again, not the keys, just the values. We've got the index, so this one's pretty easy, just an index into an array. We can't have a negative value. What that happens is the negative value gets added to the size of the array, and so you're indexing from the end of the array in that case. So -1 means the last one in the array. There's also this array slice. I can get a list of indices with a start and an end and by step. I can also do negative steps. And the one that's most interesting is probably the filter selector. Here, now the filter selector is introduced by the question mark. So this, and this is interesting. We'll see this in a second. So when I've got the question mark inside of the segment bracket, that means it's a filter selector, and that means that we're going to have an expression to choose that is going to be applied to the context value that precedes of the values that precede that segment. So it looks very much like an XPath predicate. That's within here. This is the only place where we can use that context node. And it's also the only place where we get to use this list of functions. So there's a few functions here, like I can ask for length, and that works with strings and arrays and with members. I can ask for the count. That works exactly like an XPath. I can match on a regular expression. Regular expression comes from XML schema definition, so they make a reference to that. I think that Michael K. recommended that to them. Let's see, we can search on a substring, and we can also, this value, so the expressions within the filter selector can be either comparisons or existence. So a comparison is going to compare the values of those nodes with a given value. And then the existence is just going to tell me whether or not there's something there. And I can use a not for the existence, for instance. So this value is really used in case I've got on the right, on one of the comparisons, if I have a path that could potentially produce more than one value. Value says, take the list of values that's produced from it. If there's exactly one, that's the value that we'll provide to the comparison expression. And if there's more than one, you say there's nothing. Or if there is nothing as well, there's also nothing. All right, and then there's a couple of shorthands. They're entirely equivalent to the canonical versions, so I can use .name instead of putting it inside of the square braces, and I can use the wildcards like that. Those are the only shorthands. So if I want to do some comparisons to JSON path to XPath 3.1, I didn't go all the way to XPath 4. They look very similar, I would say. So on the left-hand side, I'm saying I'm choosing the value associated with the key in a map. XPath 3.1, I've got different ways of doing that. I can use the question mark lookup operator. I can use the function form where I'm passing the key in as the argument to the function. And then I can use the map-get function. And arrays are pretty much the same thing. There isn't a shorthand for arrays in JSON path. So JSON path is 0-based, so I need to look for the 6th index in XPath because we're 1-based. But that's pretty much the same look. -1, well, I can look at last. This is where Michael K's XPath 4 is going to come in handy, because this says I'm going to descend through the tree, and every time I find an array, I'm going to take the value of the 4th element there. I didn't really have, there's not a shorthand in XPath 3.1 for that, so obviously the question mark would do quite nicely here. Otherwise, I can write a function that does the recursive descent of the tree, and then I can provide a higher order function selector for making some sort of selection with that in XPath 3.1. I can write a function for producing the indices here that correspond to this slice definition, and then I can apply it to that to an array. I have to make sure I add 1 to the index because it's 1-based. The wildcard operator, the wildcard selector, looks pretty much the same. I'm wondering if there's not some cross-pollination there. And otherwise, so one of the things you can do is within a segment, you can put multiple selectors. So this is a list. What it says is when you're traversing in the segment, when you get to that value, you're going to apply all of these selectors to it. So there's 4 of them. So what I'm saying is I'm going to get 4 times the value of the 0 positioned element in that array. So I can do that in XPath pretty easy. And I can also do that with the wildcards. I'm saying I'll copy everything in the array or the object. Again, for objects, it's just the values, it's not the keys. And then I can also say, well, I want 4 copies of it. So this is the store object that Michael K. was presenting. I put it in the margin, but it's the same one. It's in the standard. Here's some JSON path expressions that are also in the standard that operate on this object. And I've got the XPath equivalents. I think they look pretty similar. One thing that is deceptively similar, let's see if I can do this, is this question mark here in JSON path. That means I'm introducing a filter selector. Now this question mark over there, and I didn't do the same thing I did up here. This one has an implicit dot current context. And you don't have to put it in there. If you don't, it looks exactly the same. But these are two very different semantics. This one just says, I'm introducing a filter selector, and this one says, I'm looking for the value associated with the key price here. But then they look very, very similar, I think. And then I can also, Michael K., you had the example of searching for ISBN. We've got ISBN searching for it, or not ISBN. So they look also very similar. So one of the things that I've run into in JSONPath, this is from the JSONPath compliance test suite. There are about 500 examples in there. This one really threw me. I had to look at it for a long time. And that's because of nothing. So one of the things is nothing is different from an empty sequence in some ways, okay? And I won't go too much into that. But this value says, so here we're saying I want to select all of the elements within values for which this expression is true, okay? That the length of the value associated with the A key is equal to the value of this expression, okay? Now it turns out this expression here says, do a recursive send and find the values associated with the C keys. And so there's two of them, there's D and there's CD. Because there's two of them, value returns nothing. So then the length is going to be applied to each context node here. Well, when I apply it to this object, well, A has a length of 2, that's not nothing, so it doesn't match. There's no A here, and so it is nothing, so that does match. And then this one, the A is null, and the value, or the length of null is nothing, so that one matches as well. So the result expression is this. It seems quite surprising. It's very different from the effective Boolean value. In XPath, if you have two expressions that both provide an empty sequence and you compare them, what's the result? Is it true or false? It's the empty sequence, that's right. So that would not give you true. So, but in this case, nothing does match, and so really nothing really kind of matters in this case. So what can you do in JSONPath you can't do in XPath 3.1 with JSON? And I haven't found anything. I think there may be nothing, especially since if you did find sort of a corner case, you could always write a function, a user-defined function to do something with it. What can you do in XPath 3.1 with JSON that you can't do in JSONPath? Well, there's a lot of things. JSONPath is not for arbitrary evaluation. It's not for, you can't pull out just the list of member keys. There's no user-defined functions. You can't do any sort of transformation. So it's in a very different space. That means that JSONPath is really much, much simpler. So some of my conclusions, so I'll just skip ahead for one. This is one of my footnotes, is that JSONPath Wikipedia page. So it showed up in March. It was on the working group mailing list that I was following. I took a look at it, and one of the sections was talking about alternative to JSONPath. And they mentioned JSONic. They did not mention XPath 3.1. So I added it. It's Wikipedia. If you don't like what I added, you can change it, and I'll probably change it back. But this told me that even those that were developing the JSONPath specification, they were not aware, or perhaps were not aware, that XPath 3.1 could actually do a very good query of JSON. And XPath 4 is going to be excellent. So for my conclusions, I think that JSONPath and XPath 3.1 are often very similar. And I think that they read in the same way, sometimes in surprisingly similar ways. That JSONPath is not going to replace XPath 3.1 for transformations on JSON. So JSON's everywhere. We have to accept that. That's great. I think we need to be more vocal about the fact that XPath 3.1 handles JSON really well, and XPath 4 is going to handle it even better. And that people should pay attention to XPath in the JSON space and not say, well, XPath is just for XML. And so one of the other things is, so this is a new standard. There are a lot of existing implementations of JSON-Path. What I think is going to be interesting is to see what's going to happen to the existing implementations. There are a lot of them. A lot of people use it. It's very well adopted. Is there going to be some alignment? How is this new standard going to affect the existing base? Just have one other footnote. And this was, I think, one of the reviewers, I think it was you, Mike, okay, mentioned that he was interested in what this location was about. So I was looking at this. What is this location? So the original Gessner implementation and specification, you could say, well, I could ask for either the value outputs in a node list, or I could ask for a list of locations. And so you could get one or the other. If you do it twice, then you'd have both, obviously. And I've found at least one other implementation that does that. And the specification itself does use location in their output, in their example output. It's good to illustrate just where it was coming from rather than you taking the value and try to guess where it is in the query argument. The compliance test suite, on the other hand, does not give us a list of output locations. So I'm wondering how much of a requirement it is if even the compliance test suite doesn't have that. So I think that XPath has a lot of 3.1 and now 4, really is a very good competitor for JSON-Path. So I think that we need to maybe get more adoption and more recognition for that. So thank you.
Thank you very much, Alan. And we have space for questions. Stephen, over there.
Not so much a question as a comment. You asked about whether there'd be convergence. And if I look at Seriot's parsing JSON test set, he says, I did not find two libraries that exhibit this very same behavior just for parsing JSON. I would be pessimistic about convergence.
Okay. For parsing JSON, so the specification does say that the JSON input does need to be conformant to 8259 or standard 90.
Yeah.
So
this was a guy who was this was a guy who created a test set for JSON for parsers, and he doesn't find convergence there.
That's surprising because the hallmark of JSON is the simplicity in parsing it.
Exactly, one of the surprising aspects.
There is a question over there.
Yes, several comments. Thanks very much for the talk. I have sort of tried to follow the JSON-Path development and occasionally comment on what they were doing. And so there has been some cross-fertilization, and the JSON location concept in the spec was certainly informative and influential. So okay. that is an idea that has, crossed the channel in between the two communities. And of course there are people who've been involved, like Tim Bray, who know both areas well as well. On the issue, there's a general thing about standardization, which is it can come too early or too late. Standardization 20 years after the first implementation often does fail. Because the existing variants are so well entrenched that it's very hard to bring them into line and to find the business case for changing your implementation to conform to a standard, especially if other people don't appear to be doing that. But I think one point I would make that perhaps you didn't highlight is that JSON-Path does have many of the advantages of XPath 1.0. I mean, Tim Bray, I think, is on record as saying the reason XML succeeded is that you can implement it in a weekend. And the same can be said for XPath 1.0, and the same can be said for JSON-Path. It's a small language. It can be implemented by people in their spare time. And that's often a very great impetus to making something successful. XPath 3.1 and XPath 4.0 implementations are thin on the ground because they are expensive to produce, and that's an important factor.
Okay, we have a question from Peter.
Thanks for your talk. XML. With invisible XML, hi, Alan.
Was looking.
Thanks for your
Hey,
talk.
Peter.
So you're mentioning that JSONic is mentioned on the Wikipedia page, and JSONic attempts to do XPath for JSON. So would effectively JSONic be the solution for the JSON community?
I couldn't answer to that. I definitely couldn't.
Would that be? I would expect that to be conformant to XPath 3.1 and using the syntax that JSON people like.
So I don't know enough about JSONic to answer that. So I'm sorry. I just, in terms of alternatives, I was surprised to see JSONic put there and not XPath 3.1, since I think JSONic is not a standard. It's an implementation, but it's not a standard in the W3C sense. So I would have thought that we would have included that. But don't you think that means that there's not enough recognition that XPath 3.1 handles JSON?
I think the syntactic differences make it hard for the other community to understand XML.
Okay, well, but so you said the syntactic differences make it hard. I tried to argue that they're very close. So I think we don't agree.
The last question.
Do we expect YML path?
Ooh, that's a better question. So I personally use YAML a lot. I really hate it. And I haven't seen anything that really produces YAML the way that things produce XML. It's not really part of a pipeline. It's a source document. So I'm not sure if we're really going to be doing something. But YAML, of course, it creates JSON. It's a different serialization of JSON, but the outcome of it is JSON. So we could definitely use JSONPath or XPath 3.1 or JSONic on the output of YAML. So I think it's quite applicable.
Okay, thank you very much again. Yeah, if you can give me this.
You don't want to pick my pocket?
No. You know, it can be quite.
Hello, everyone. I am Edward Porter. I'm going to sit down because I have to use my keyboard at some point. Just makes it easier. So I know I'm standing in the way of lunch. Good news, this may be introductory for some of you, but for others, maybe it'll be interesting and spark your appetite. I don't know. So brief introduction as to who I am. I'm Edward Porter. I'm the tech lead for documentation publishing in our doc delivery DevOps engineering group. That's a rather new grouping, and I think it informs my approach in this project. Since going into the DevOps group, we've changed a lot of our tooling to be more microservices oriented and containerized. Like a lot of our microservices now are an internal instance of Kubernetes. And so you may be familiar with using Kubernetes or using Docker for that, but in this talk, I'm going to talk about containerizing our actual build tooling so we can kind of make it easier to share with people. This is useful for us at SAS because we're an analytics company, we have our own programming language, we have very smart people who don't trust tech writers to document their own documentation. We have people who've patented algorithms and whatnot, and so they'll actually document their own corners of the SAS programming language, or in this case, document directly in their source code. And we're trying to facilitate that. So, quick overview. I'll give you some conceptual landmarks in Docker if you're not familiar with containerization and whatnot, and then I'll talk about my use case, and I'll demo it, and some brief considerations if you pursue this path, and talk about some next steps. So, Docker is, if you're not familiar, a software platform for virtualizing OS and isolating applications. Generally speaking, that's used in microservices. You package up your software, your microservice, and then you can deploy it basically anywhere very easily, isolated from any other applications on that system, unless you tell it otherwise. Those containers are created by images, which is like a recipe for that OS and anything stacked on top of it. These images can be based on one another, and I'll show how that's relevant in this situation and some possible next steps. So this is a brief generalization or visualization I stole from Docker's website. This is the daemon, which is what you would interact with if you were running it on your computer or running it somewhere else. And I'll show you running at the command line these specific commands to either like build an image or just run one or pull one from a relevant registry. So isn't Docker just for microservices? Or why would you containerize your tooling? So generally speaking, yeah, it's for microservices. It's very easy to run long-standing processes if you've containerized it. It makes it easier to build redundancy. You can have multiple containers running at the same time. If one falls down, you have a load balancer in front of it, and that one will be replaced if you're using like Kubernetes. In any case, you can also do this for once run situations, for temporary instances. So I've created an image that you just run like you would run a normal command line application. So you just Docker run blah, 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 pass in your parameters, and it ends when it's done. Why is this useful? Because it allows for uniformity. So I tell the Docker or the developers of this source to, hey, just go run Docker pull and then pass your source code through this, and you'll get out the same results that you will get when your pipeline, using my same image, builds. So it makes it very easy to distribute. As I mentioned later on, I just publish to our internal Docker registry, and then they Docker pull and get what they need. It also makes it plug and play with the CI pipeline, as I mentioned. Every modern continuous integration stack will easily let you pick up an image and run on top of it. So this project is using GitLab, but internally we're all kind of moving to GitHub, an enterprise version of that. And both, as well as Jenkins, easily allow you to interact with and use Docker. And then, yeah, there's 0 environment setup. If you have Docker installed, I guess that would be the setup. Otherwise, once you've got it, you don't need to worry about incompatibilities, about making sure that your Java command or class path is just right, or that you have all the dependencies pulled down for a given node package or Python, whatever. So, yeah, in this particular instance, we have documentation embedded in the source that's either written in C or in SAS, the programming language. And these projects are versioned in GitLab. These developers have been delivering documentation written, tagged up as Doxygen. You may be familiar with that if you've used C or probably not SAS, but in any case, it's all just comments directly in their source code. They can run a step in their builds that builds deliverables that are then delivered to their users, generally packaged with the deliverable, the actual packages we're sending out to customers. But now there's more emphasis on making sure that all of our documentation lives in Help Center, our web application, our documentation.sas.com. And so they want to both still be able to deliver their content in the deliverables to customers, because some customers are black sites. They want to be able to, or they would like to be able to edit that content for their specific needs. But then also they would like the content delivered to our forward-facing customer site. We could easily do that if we just lifted and shifted to, we have our own proprietary DTD and publishing system called XIS, XML Information System. It's very original. But as I said, they would like to continue to edit their content in their source. So what I did in this instance was to containerize it. We've got a brief overview. They have their source code, and now with this Doxygen transform image, they can drop that into their CI/CD pipeline. It will generate, first their Doxygen transform will generate Doxygen XML, and then my new image is dropped into another step after that, and they'll take all the XML files and they will drop that into CVS, where all of our documentation still lives. Long story, it's going to GitHub, but it's a painful process to move from one to the other. They're very different. And then once it is actually in our traditional documentation project repository, it's very easy to pipe straight to Help Center and then go to pre-publish, so on and so forth. So in the image, and why this is useful, I can package up everything. So we have our own array of Java extensions and a whole build environment. But in this case, all I really need is the ability to build our custom EIDs, which is a compressed UUID. And we package that in a jar. It handles, it also contains a Saxon processor and an initializer, so we can mount our extension. They can then, when my transformations run, it will take Doxygen XML, which doesn't have great identity on individual elements, and then I can use my UUID to generate stable links and all that good jazz and stuff valid against our DTD. It's built on top of a base image that is internally managed, which is nice because I don't have to be too concerned about security vulnerabilities, that sort of thing. And then the entry point shell script is actually what the user sort of interacts with by running Docker run. Docker run will run that shell script, which actually just kind of does the jar and all that good jazz. So let's see it in action. Here we have the Docker file. This is a bit of subterfuge. We have our own internal build tooling that's based on Gradle. So I actually don't write Docker files anymore. I write something in YAML, delightfully, that will eventually become a Docker file. But in any case, this represents what comes out of it. And this is our internal universal base image. But if you were interested in doing something like this for yourself, there's myriad ways you could get access to like the Java environment. One that's very good is Amazon manages one, and they promise that it will always be up to date security-wise, and that's based on Linux Alpine, so it's nice and secure. If you have another language of choice, if you'd rather write in Go or Python or whatever, there's a base image out there. It's very easy to find. You can go to registry.docker.com and find it. In any case, as I said, these Docker files are basically just recipes. So I say, hey, copy over the results of my build, which would land in this build folder, into the Docker container, and then the second part is where I would like it mounted inside my container. The same thing, take my XSL, plop it over there, and then I'm telling Docker, hey, expect a couple environment variables, and then I'm declaring, or create a couple of environment variables, and these are the just standards which I expect the user will override eventually. And then I've got another one for the class path, so that way everything knows where, Java knows where to find things. So yeah. Here we have the entry point. As I said, there's actually a shell script now, but this is an earlier version. But the shell script more or less does this. It runs my particular class. And then I've also told users when they're doing this to mount an input and output directory in Docker when they're running it. And then my script expects to find the input and output files they specify. So here is actually how they would run it. And it's, first they would actually, let's see, pull. So if you don't have it, you would pull from the registry. This is our internal registry.unix.sas. So this is basically our internal instance of a Docker registry because security. And once they've pulled it, it's very simple to run. Like I said, they know that they need to, right here, this is a volume mount. So I'm saying, hey, go and look in this input folder over here. And that's where you'll find your input. You mount the input, so on and so forth. The same with the output, which I'd like in this folder. They run it. I compiled this in a different platform. It doesn't matter. It still works. So it runs, boom. It's very easy for them to use, but more importantly, it's easy for users to use, or for their engineering group to use when they create their CI pipeline. So I'm just showing you here, this is jobs run whenever they run a commit. So when the developers in this risk group write new code, it runs myriad steps, and one of which is docgen, and that's when my container runs after the Doxygen XML is built, as well as the HTML and all that good jazz. It'll generate my XIS XML. Was there anything else I wanted to show? Yeah, so you get to go from the documentation in their raw source over here. This is a SAS macro program. And yeah, so it goes from here down here. Generates this Doxygen XML, which then generates this lovely document DTD. We name things very originally. XML, and then, yeah, eventually, this is the same content. And that's all nice. It's very easy to, transform things. We do that all the time. But what's cool is that it's all done in a way that is easily usable in multiple places. Let's get back to this. So this is their, I don't want that. How do I get back to just, okay. There we go. So this is a representation of the CI/CD pipeline. So they, as I described, they'll revise their source, they'll push it, and as part of their pipeline build, it recognizes the change set and recognizes all the new files that have changed. It'll run through this Doxygen transform and generate a bunch of XIS XML files, which then their pipeline will drop into CVS. They can preview it, and once they like that, then they can commit the CVS preview or the CVS content, and it will automatically build and be delivered to our site. So a couple considerations if you are pursuing using Docker, which this, again, may be review for some, but very important for us is to always use the lightest base image you can. We're using Alpine and then as little on top of it as possible. And in my case, I'm putting nothing on top of it because I'm using a base image that someone else manages. And that would work well for you as well if you find like this Amazon one that they promise to always keep up to date, dealing with CVEs and whatnot. If you need much more, you might want to think about what you're doing and think about ways to strip your program down. Generally speaking, you shouldn't leave your user as root, but there are caveats. I still run as root because I discovered incompatibilities with Windows and Linux. So if you write to subdirectories in a mounted folder in Linux, that's fine. But if you do it in Windows, there are permissions problems and it won't work. So I now run in root knowing that it doesn't matter a great deal since this is not a long running process. So hopefully no one will exploit that. Secrets management can be cumbersome. So it's very easy in the cloud or in a CI pipeline. You store the secret and that's not a problem. It's not a problem for me now, but so we're using Saxon HE. We do have an enterprise license, but I was able to avoid it with the way, we were just not using anything that we need professional or anything like that. However, if we did, it's easy to store that secret in the cloud, but it's much more convoluted to distribute sensitive information to end users. So you could theoretically put that in your image, but then they could probably get it out. And that's something it's just a consideration. So some future work. I created this project pretty quickly at work. It works, it's great. But I think upon reflection, it would make more sense for me to make a base image that just contains the controller and not just this, but other, I'm running late. Sorry, I know, I took too long. In any case, it would be better to build a base image with just the controller and then to add XML on top, so that way it would be reusable for different purposes. And to that end, I've mentioned to Norm, like, I think that eventually it would be nice if there were like a Saxon Docker image. That exists for like Antenna House's CLI, so a way for anyone out there to pick up Saxon without needing to create your own image with the jar in place or Saxon C in place, so that you could do what I did more quickly. There are some images, but they're just community run, and yeah. I think that's about it. Does anyone have any quick questions?
Thank you very much, Ed. So we have time for one question. There is a question over there. Anyway, you will have plenty of time during the lunch.
Hello. At Pantapix, you are also trying to use fast the same process to be able to use some pipeline transformation, and maybe one of the problems we are facing is, for example, to be able to pass the output of one transformation to the other one. And doing it with the volume, it can be done if you are using you have all the steps in one. But if you are splitting to have, to have more control, how can you do it?
I think it depends on the CI platform that you're using. So in GitHub, you could use, you could pass from one step or one job to another, but you need to specifically, you need to look it up more or less. I can't remember off the top of my head, but we do that in our new build pipeline for our GitHub-based projects.
Okay, thank you very much. We are running a little bit out of time, so I would suggest postponing questions. For lunch, you can catch Ed here. Thank you very much again. Thank you.
Just
And
before you
before,
leave. Yes.
stay sitting, because this day will be full of adventure. So, as you already have been informed, the social dinner will be in different place. You will get more details in the afternoon, but this morning we realized that even the lunch will be in different place than yesterday. But it's not very difficult. It will be just on the second floor. The reason is that the Czech broadcasting company is recording some interviews with people who are taking part in elections, and it's in the room which is next to the restaurant, and they have very sensitive devices or whatever. So they ask us to do the lunch on different place, so it will be just on the second floor. So we will just go and to the usual place and take lift to the second floor or stairs on the right side. You can watch this video which is showing the right way. So just don't go to the third floor for lunch, only to the second floor. Enjoy your lunch, and we will continue here at 2:30.
Yes.
And one more thing from Mohammed.
While you enjoy this video done by Holo, whatever VR, so I just wanted to point two things. Demo Jam, so continue to come to me so I can register you for tonight. Different place also. We come back later to that. And the second thing, we have a last-minute sponsor for the Demo Jam that proposes a free pass for Declarative Amsterdam, if I'm correct. Is it? So please register so you can be on the list of the people that could be elected or just winning the free pass. Thank you very much. Two?
Yes. It's for later. That's for later. Next time, apply for 30 minutes. I know. social dinner will be is just go to the schedule for this day on the conference website, then click on the social dinner link, and there is link to the Google Maps, which will show you the location, and you can just click directions, and it will offer you how to walk there or use public transport, or you can take taxi. It depends on you. And if you prefer to walk there from the conference location from here, we recommend clicking on the last link, and it will open the Google Maps with some kind of pre-configured recommended walking directions. It's quite nice walk because it uses old rails and goes through the tunnel, goes over very new pedestrian bridge, and it's close to the river. So if you would prefer to stretch your legs after the conference, we recommend taking this route. But of course, you can take public transport, taxi, or whatever. Okay, so I think you will be able to find it, and there are also a couple of those sheets of paper at the registration desk where there are QR codes which you can scan, and they will point to this Google map with walking directions, or the second QR code will give you the public transport directions for dinner location. And also one more thing, because I think that one of the most important thing about conferences is just to discuss with other people ideas and technologies. There is XML Slack channel. So if you like to discuss XML topics, including XSLT, using JSON with XPath and whatever, I recommend you to join this Slack channel, because there is very nice discussion about XML technologies, and as you know, at least when I was younger, there were mailing lists. They are still there, but I think that the usage of mailing lists is slowly decreasing, and people are used to use some newer technologies like Slack, which is just IRC on steroids, and it's not that open, but it's used by people, so I just would like to welcome you to join XML.com Slack. There is generic channel for XML, and there is also specific channel just for this conference. So you can just join the channel and look around here. Okay, thank you.
Thank you. So we start this session of the afternoon with Markdown and QTI in InDesign. HTML, yes.
You touch the buttons.
Somebody else did that.
Yeah, that's good. Go ahead.
And then switch the input.
Input should be switched.
How's that? Hello. Dobre odpoledne. Hope I got that right. My name's Mark Dunn. I'm a content engineer at Oxford University Press. OUP's been publishing books for over 400 years. For most of that time, I've been helping them to produce digital publications, so online platform and ebooks. This is the first time I've been asked to produce a print output. And I wanted to talk about it because I don't think anyone else is doing this. I don't quite know why, maybe someone can tell me. No AI was used in the presentation of this project. I didn't have time to train an AI to do this for me, and frankly, where's the fun in that anyway? So what we're trying to do is OUP, amongst many other things, publishes worksheets for students learning English.
So these are activities where a student will read a text, look at an image, listen to an audio, and then answer questions about it. And there's lots of different kinds of activities that they're asked to do. And we produce these in print and digital formats. The standard way that these are produced in publishing is to create the content in Microsoft Word and import it into InDesign, which I'll talk a little bit more about. The content authors and the designers work together in InDesign to finalize the content and the layout. And then you can export XML from InDesign. And what that leads to is an XML last workflow with some disadvantages. So your digital product lags some time behind the print. The authors, the content creators, really only think about the print format. They tend not to consider the digital output. And it's quite expensive. InDesign operators are a lot more expensive than XML capture suppliers. At OUP, we don't yet have XML in the workflow, so we've actually got two separate workflows. So we've got the Microsoft Word imported into InDesign, and we've got a separate process for creating the digital product, which is essentially copying the text into an authoring environment on the platform. And we end up with the same kind of disadvantages. We still have a focus mainly on the print format. The digital is still some way behind, and it's still expensive. So what I was asked to do, or to help with, was to produce a single source XML workflow for this content, including a single source for the corrections and updates. So at the moment, we're making any corrections twice because of the two separate workflows. We want to publish them at the same time, and we want to reduce the amount of manual effort in this process and eliminate the duplication that we have right now. And the way that we're doing this is with a transformation, XSLT, from a source XML format, which is QTI, which I'll explain a bit about shortly, into InDesign. So not everyone will be familiar with InDesign. I know I'm still not, but it's an application for typesetting. And the typical way that you work with InDesign, as I've said, you import your content usually from Microsoft Word, but you can import XML as well. You then arrange the content on what are called spreads, more on that in a sec. You apply paragraph and character styles, and when you're happy, you press a button, export a PDF, and that's your print. That's what you print. So there's a couple of bits of jargon that I need to talk about. First one is IDML. So the only reason this process is possible at all is that InDesign has an XML serialization, essentially. And it's actually a zip package of lots of XML files for the different components of the document. Weirdly, it's not the native format that InDesign uses. The native format produces files that are 10 times bigger. Adobe seems to regard IDML only now as an interchange format, so you can save your document in one version of InDesign and open it in a different version. But when the spec was first produced, and I dug up documentation from a random place on the internet, it's not made available by Adobe anymore. But the last spec that they produced publicly encouraged people to do exactly what I'm doing, produce an IDML document from your data source, but nobody seems to be doing it. If you search IDML on Stack Overflow, there's fewer than 200 questions asked about it, and most of them haven't been answered. So I mentioned a spread. A spread is 1 or 2 pages, so designers often think about a double-page spread, like in a magazine. And it's an XML file in the IDML package. In the spread are various kinds of objects. So you can have text frames, more on that in a moment. images, lines, and various kinds of geometric objects, and lots of associated properties that describe how InDesign will present them on the page. There's also a concept called a master spread, which you don't see in your output, but it's kind of a template. So your page that's on an actual spread can inherit its properties from a master spread and get its design from there. So I mentioned text frame. A text frame is an object on a spread. It's like a window onto the content. The content is held separately in a story, more on that in a sec, which is linked to the text frame. And the exciting thing about text frames is that you can chain them together. So if your text frame is too small for the content, you can link it to another one, and the content will overflow into the next one. So that's what this screenshot shows, is there's two columns and it's just an overflow. And that's how you do many pages of worksheets and books. So story is where the content is held. In the version of using InDesign that imports XML, you don't see the content straight away. It puts it into another file in the package called a backing story. And you don't see the content straight away. You do see, if you open the structured view, you do see kind of a hierarchy of the XML structure. And then what you do in the manual process is you drag nodes from that onto your page, your spread, and that process creates a text frame, and it snips out the content from the backing story, and it creates a story that's linked to the text frame. So you've now got a window on your spread onto the content that's behind it. At that point, you can start applying your paragraph and character styles. So this is just, I hope that's not too small. It's a hierarchy of the story XML. So in it, you might be able to see that there are paragraph and character style elements. And there's also elements called XML elements and XML attributes. And they're kind of an imprint of the source XML. And this is going to be very important in the process, that we retain this imprint. And I'll explain why shortly. So QTI, again, you might not be familiar with QTI. It's an industry standard model for assessment content. Contains a mixture of presentational elements, which are actually XHTML, and more kind of semantic functional elements for the digital assessment. Lots of different kinds of interaction that are supported. So we're using, for example, multiple choice, text entry, ordering, matching, that sort of thing. We hold our QTI together as a package of, again, separate XML files. So we have a test file, which is linked to, that's the overall worksheet. It's linked to a series of the assessments, which are individual XML files. And there's a manifest in the package that basically describes all the different resources, including the media assets, and has metadata about those. And we use all of the different kinds of files in this process. Just to show you a quick example of what it looks like, in case you miss angle brackets. So you can see, again, hope it's not too small, some HTML markup, div and paragraph and images, and span, and some of the QTI specific things, so the introduction, the rubric block, and the interaction is just an empty element there, which is going to become a write-on line in the print, or a text box in the digital format. Oh yeah, at this point in the process, we will normally not have images. We'll know that there are going to be images, so we put in a placeholder, and in the manifest, when we write the metadata about the image, we include what's called a media brief, so a description of what we want the image to look like, and then somebody else goes away and produces it. A bit more QTI, so in a separate part of the activity file, you can identify what the correct response is, and that's linked to the interaction using an ID. Yeah, in the digital environments, the QTI package also contains a thing called a response processing template, which has some fairly clunky logic for scoring the activity. So what parts of this process are we going to automate? So we're going to start with this XML source. We want to automate the import of the XML. We want to automate that process of dragging and dropping the nodes and creating text frames. And we want to automate, at least at the first pass, applying the styles. So there's a mapping between the XML elements, attributes, their values, and particular named styles in the InDesign. In order to do this, one thing we need is a template file. So this is a blank InDesign document that contains the master spreads with the design, the styles that we're going to map to, and text frame placeholders. So we've got a target for where we're going to put our content. And in broad outline, all we do is unzip this template, XSLT the QTI source into stories, starting with the backing story. We include that imprint of the sourse XML, which is very important. We create the spreads and the text frames. We clone the master spreads. There's a few other things we have to tinker with. So there's IDML has its own manifest called a design map, which references all the different files in the package. So we create a new file, so we have to update the design map. We zip it all up again, and that's the document. This is all executed with an XPath pipeline, and I wanted to credit Akim, who gave me help. Can't see him. With writing and understanding XPath. So we've done all this automation. Technical details are not rocket science, they're in the paper. And we get an output with a few bells and whistles added in the transformation. So there's no numbering in the source XML because we might not need it in the digital output, so the numbering's added. What else? We pull some of the text on the page from the manifest. We don't have images, so we've got a placeholder, and the placeholder's got the media brief. What else? We've got a worked example, and this was identified with a class in the HTML, and we can use that and pull in the response, and so we can show the correct answer for that one example activity. And they're probably too small, but there are footers on the page. Don't need to worry about those. They're just copied from the template master spread. So I think that's quite good. I hand it over to the designer, and he goes, leave it with me. He wants to improve the layout, and that's his job. So he wants to fit the whole thing more nicely on the page. He does various bits of alteration and titivation. So the image placeholders are resized, and we get a nice grid. They're aligned better with the text. And it all looks nice. And then what happens is somebody decides we need to make a change to the content. Maybe there's a typo. curriculum change, all sorts of things can lead to a content change. Now, the typical way of doing this up to now is to work in InDesign. You can edit the content in InDesign. InDesign is not an XML editor, so we've not chosen to go down that path. What we want to do is to update the source XML, single source, so we only have to update it once. It can be updated for the digital as well. And we want to rerun the transformation. But we don't want to reset the layout. We want to preserve what the designer has done in his step. He doesn't want to have to redo that work. So, how we do this? We've now got two sources. We've got the updated source XML. We've got instead of the blank template, we've got the IDML output that's been updated. And this has got the imprint of the source QTI in it. So when we retransform the source QTI, we can look at the IDML story and go, have I got this node already? And if it finds the node, it can also find the designer's work, because all the designer's work, the alignment and whatever, it's attributes and children within this structure. So we can find the node in the IDML and copy the styling overrides so that we preserve them when we produce the new output. So we can change various things. The heading, the media brief, the activity, and the layout's preserved. One more example, because there's a lot of different things you can do in InDesign. So this is a different kind of activity. There's a reading text and multiple choice options. And this one actually looks pretty bad because the reading text is in a text frame. It's too short. It's too long for the text frame, so you're not actually seeing all of the text. And the spacing is a bit weird. So this time we improve it. So this is, I'm obliged to say this is the work of me playing around, not the work of a professional designer. But we make various changes. So we expand the reading text frame so we can see all the text, put a bit of shading. We've added spacing to the heading. We've added some drop caps. We've laid out the answer options on single lines, so it looks a bit nicer. And again, we can preserve we can change text all over the place here and preserve the layout. So the heading can change, the paragraphs can change, fixed my typo, reordered the answers. It still works. Okay, how are we doing? So the next thing we wanted to do is to add images. So we've got the image now. It can be added as an asset to the QTI package. We can add a reference to the file. So before and after, just add a file reference. And okay, job done. No, hang on, it went wrong. What I didn't take account of when I first did the process is that there's basically a big array of numbers in InDesign that tell you how to do the image. If you don't do anything specific to the image, it'll just plonk it on the page, add its original size at a location that is relative to the original site of the text frame. So the text frame has been moved and it's been resized. So the image is now in the wrong place and it's the wrong size. So you have to do a big calculation. It's not entirely trivial on the numbers to scale the image and center it and position it correctly. There was one, I skipped over a thing that I was going to say, actually. I think I've got time. Sorry to go back. When I first produced this output, I didn't get the media brief. I got empty text boxes, text frames. And I could look at the IDML and go, well, the text is there in a story, and the story's linked to the text frame, but I'm not seeing it. So I had to go away and have an existential crisis for a day or two, and eventually had a bit of a brute force attack at it. And it turned out, maybe this is why nobody else is doing this, it turned out that there's multiple stories going on here. So there's a story containing the activity text, and there are separate stories with the media brief. And in the design map, which has references to all of these stories, it turns out, the documentation doesn't tell you, that the order of the stories is important. So my story with the activity text had to come before the story with the media brief. Don't know why. Once I reordered it, got the output. Okay. And now I can't go forward again. Nope, it's gone. Why can't I go forward? Okay. Images. So that's more or less it. There's lots more to do. This is essentially a proof of concept. We've done 10 of our activity types. There's a lot more to do. We need to do boring things like figure out how to manage the content and the assets. One thing I'd like to do is transform marks. So the content's still created in Word. I would like to write a transformation from the Word to the QTI. At the moment, we assume that an outsourced capture house will do it for us. What we're definitely going to do is extend this to books. So in the bits data model, transform that to InDesign. And our content creators are in-house. I would like them to be confident in editing XML. So I want to write an authoring framework with a bit of Schematron Quick Fix. I've been desperate to use Schematron Quick Fix for years. Haven't had an excuse to do it. This is pending the availability of a proper designer to create a nice-looking authoring framework. So finally, I think the key insights I had from this project. One was there's an industry standard model for assessments. Let's use it, not reinvent the wheel. There's a serialization in XML for InDesign, which is good. Couldn't have done it without that. We want to mimic as closely as possible in the transformation the way InDesign works in terms of importing XML and placing the text. The logic was a lot easier when doing that. We have to retain the imprint of the source XML in the IDML stories so that we can do the update process. And to avoid hideous complications, our updates processes, content updates in the XML, layout updates in InDesign, merge the two. So what I meant to say, was that OUP's had a couple of attempts before now at doing this, and both got bogged down because one, they tried to use a bespoke data model, which was just trying to hit a moving target, and the logic around the transformation was very complicated, and they also got bogged down in trying to round trip. So they thought they could update the content in InDesign and export the XML, and that could be your master XML for the digital, and it didn't work. So I tried to keep it simple, and it works. And that's me. Any questions?
Thank you very much. We have maybe 1 minute for one question. Sure.
Hello. I just want to suggest another next step for you. The server version of InDesign has a JavaScript interface so that you can automatically create master spreads and populate them with XML content.
I'll make a note. JavaScript server version. Thank you.
Hello, Mark.
Hi, Tom.
First of all, congratulations. Print from XML First is a dream from when I was with you at OUP, and I'm really pleased to see you achieve it. My question is, how difficult is it to separate the content updates from the layout updates? And is there some fuzziness around the two, and how do you manage that?
That is a really good question. So one of the reasons you might make a content update is you look at it on the page and you think, oh, it's too short or it overruns. So you want to remove or add a few words just so it fills the page nicely. And if you're doing that in the source XML, then you can't. It's a while before you see it. I mean, it's a button press in Oxygen to run the XProc, but it's still not what people intuitively want to do. So we've come up with various bits of guidance around operating this process. And one is, well, you can update text in InDesign if you want to preview your changes, but you still need to make it in the QTI. So it is a bit fuzzy, and if I was a creator of that content, I'd think it was still duplication because you're doing it in InDesign and then you're doing it in the QTI. We haven't got a neat way around it, but for typos and stuff, it's fairly straightforward just to update the XML and press a button, get the new output.
Okay, one last quick question.
Yeah, in Latin they say that the venom is in the tail. To me, it seems that's the head. If I look at one of your last slides, you mention your authors and editors. And I wonder what they feel about this. Especially when your editors are employed by you, but your authors are often external. And well, how do they feel about this? Because normal people outside of this room tend to not to overly like XML.
True. So right now the authors are working in Word and then in InDesign. And the first step in socializing this is getting them to relinquish a little bit of control. So we say, well, you can create the word. We're gonna hand it out to some place in Asia, and they're going to create XML from it. And we'll check it. It'll look fine. That's a hurdle we have to get over because they lose a bit of control at that point. And when they want a correction, well, they can specify what the correction is, but they can't make it. Somebody else has to go and make it. Someone else has to go and make it. So I think authors being in-house. How's it going?
Keep going.
Sorry.
We're streaming.
I didn't press the button. Authors being in-house can be trained, and they're less reluctant than authors who are not employed by the press to use XML. They're more willing to say, okay, to be persuaded that they can use an authoring tool. It's not easy, but it's more easy with in-house people who you pay than with external authors.
Where? Do you have some pocket? No, yeah, on the side. Yeah.
Thank you.
Thank you. Thank you again. Sorry. You, of course, have to continue this discussion over the coffee break because it seems very interesting. And it has a lot of potential if I understand correctly. Joint presentation, joint build presentation presented by presenter about round-trip data document editing.
So, thank you. Hi, my name is Alexandra von Kriegern. I'm from Berlin, Germany, and I am senior engineer at Evolve Binary. So, I'm going to talk about Petal, our web-based in-browser open source WYSIWYG editor specifically designed for technical documentation. So a little bit about me and my colleague. I come from a web development and design background and have dealt with front-end development and CSS in particular since 2008, and have then worked with XML, XSDB, XQuery since 2015. And I have collaborated closely with my colleagues Yunus Bahloul and Adam Retter. And Yunus was supposed to be here on stage with me today, but due to geopolitical circumstances, he can't be here today. So I'm presenting here on behalf of my team. So if you have attended Declarative Amsterdam in 2021, you might have already heard of Petal, which was basically created by my former colleague Sharafuddin Shara, and he has laid the groundworks that we have built upon. So why did we need to create an editor? Whilst developing our own products, Elemental and FusionDB, we needed a visual documentation. We needed a visual documentation editor that runs within a web browser. And it is very easy for people to contribute, to create new pages and everything, so that it should be very easy for collaborators to contribute and without putting any technical challenges upon them. So make it very easy, like you would expect from editing a wiki page. So this is the basic idea we had in mind. And then after the idea was clear what we needed to decide which is the correct format to do it, to work in, or to author our technical documentation in. And we considered several formats, like very easy Markdown or respec, and we thought they were really far too simple for the needs of a technical documentation. So we settled for a more complex one, or we considered more complex one, like DITA or DocBook, which seemed to be the obvious choice. But in the end, we thought that in combination with the web editor might be too complex, because then we would have handled, as you see for DITA, over 600 elements. So how to transform them into being displayed in a web editor. So we decided DITA was not the right choice, but then we settled for a subset. So meaning we settled for lightweight DITA. So I would like to know who has heard of lightweight DITA? A quarter of the audience. And who has actually worked with it? Okay, so 3 or 4. That's okay. So
maybe I did, because I think 600 is not really fair, because in practice you use less.
Sorry, say that last.
You don't use them all.
Yes, but if you want to have a transformation, you have to consider every possible element. So in that case, we had to narrow it down, and of course, lightweight DITA has around 50 elements. So this is a little bit more to handle. So the complexity grows exponentially. So that was the perfect choice, and it covers all our needs. And and it also has the good parts of DITA. So we have still the expressiveness, but on the same side, it's simple.
And if you deal with LW data, you have multiple authoring formats. So let me quickly show them. So you can, LW data documents can be authored as HTML, which is then called HData. You can also author it in Markdown or as Markdown, which is called MData. Or you can have XML, and which is called XData. Oh, I'm sorry. Now you see what I mean. LW data also defines mappings between all these formats, enabling collaboration across those markup languages. And as our toolbelt has mainly or basically XML documents, XML tools, a difference, we chose XData as our authoring format. XData is a subset of data with new multimedia element types like audio and video, added to support interoperability with HTML5. We knew we needed to be able to pass XML as data as JSON to a web editor tool. And there was no official support of any JSON authoring format available for LW data. So we decided to create our own format called JData. Okay, so JData, to explain that, is a JSON representation of an LW data document, and it represents the serialization of the object or a file to another data sink. Its main purpose is to make it easy to process and generate LW data content using modern web technologies. So by creating our new JData format, we closed the missing link between creating XData documents and utilizing and editing them with a web-based editor. So, whoops, now I'm back again. Once we were clear about the documentation format, we had to identify a web-based editor that is able to deal with LW data documents. Ideally, it would have been open source, free to use, but failing to identify any existing web editor tool, we decided to build our own. And luckily, we were already aware of ProseMirror, which is a rich text browser-based WYSIWYG editor that can be extended and customized with your own schema and interface to fit many different formats. ProseMirror is a toolkit for building rich text editors we have used for building our own XData text editor. ProseMirror is written in TypeScript, and those who are not aware of TypeScript, it is a superset of JavaScript with built-in security checks and strict type checking, sorry. But in the end, it compiles down to plain JavaScript so that it can run in a web browser. In order to use ProseMirror, you have to include you have to do just two things. You have to, sorry, no, okay. Include the JavaScript library into your web page, and you have to pass ProseMirror two pieces of information, which is the ProseMirror node and the ProseMirror schema. And both are JavaScript objects, and the schema is necessary for ProseMirror to also, or defines which of the elements are blocks and marks, and this is ProseMirror specific. So marks, as you can see, are inline elements, markup elements like italics, bold, superscript, subscript, etc. And blocks are mainly paragraphs, title. And this is what ProseMirror needs to know.
The microphone keeps switching on.
Yeah, no, I realize it. It's a little bit distracting, sorry. But there it is again. I don't know. There's something, yes. Battery?
Go ahead.
Okay.
Keep going. I think that sometimes they can just adjust levels. So keep going.
Okay, yeah, I'm sorry. I tried to be louder, but okay then. So,
Yes. I think oops. Yeah, now I mixed up. Okay, so why did we want to use ProseMirror? So obviously ProseMirror is an excellent and proven tool which is very customizable and adaptable, so that was the good thing. We could pass on it takes on any schema, it takes on a lot of document formats. So that was the basic decision. And then it has also an excellent community that is very supportive, and we have made a lot of questions and got a quick response from the creator of ProseMirror, so that was an excellent work experience. And we wanted Petal to be open source, an open source tool, of course. And ProseMirror is open source. That was a great plus. And its license is compatible with our goals. And in order to, we already found an existing tool, it really sped up our own development, so we didn't have to reinvent the wheel. So therefore, we concluded we would develop an open source in-browse LWData editor based on ProseMirror. And therefore, Petal was born. Petal consists of an LWData library and the editor component, which we call ProseMirror LWData. So these core components I'm going to look at a little bit closer. The library components, LWData AST and LWData XData, are responsible for the serialization and deserialization of XML, which is in that case XData, to and from JSON, which is data. JData. That's the difference. And the second, not sure. Sorry, yes. And yeah, correct. Not sure if I did. Yes. I think I skipped this, sorry. ProseMirror LWData creates ProseMirror documents from JData and sets up an editor to edit the components on a web page. So library is responsible, in short, for the serialization transformation, and ProseMirror LWData is responsible for setting it up in a web editor. The LWData library lets us convert XML to JSON and back to JSON and back again. By converting XData into JSON, the LWData library makes it possible to handle and process XData files in the browser and on the web. JSON is an established format for working with JavaScript or TypeScript on the web. The LWData library passes an XData document into an abstract syntax tree, AST, and then converts it into a JData object. The library also performs validation to make sure that the parsed documents are compliant with the LWData's DTD. The ProseMirror LWData package generates ProseMirror documents from JData JSON and is an extension of the ProseMirror editor for editing LWData files. It provides a visual editor as well as a visual layout mode for the document structure, which is a debug mode. I'm going to show this in a minute. ProseMirror LWData contains all the logic for the editor interface, and apart from the text editing tools, also contains a document upload and download facility. It also generates a schema containing the definition of all LWData elements, the relation between them, and how to properly display them on a web page. So how does the transformation work? I'm going to show this. So the LWData library parses an XData document into an abstract syntax tree, and then converts it into a set of JData objects, starting with the document node object, then a subtree of the rest of the nodes. Each node expects a predefined set of attributes when it is created, as well as an acceptable set of children, thus validating the XData document during the transformation. Each JData object can generate its own JData representation, which includes the JData representation of its entire subtree, so that by generating the JData of the document node, you get a JData representation of the entire document. Alternatively, the library can do the reverse operation. So it will read a JData document, create a set of JData objects from it, and then serializes them into an XData object. Oops. Now bringing it all together, the round trip. I want to show you the round trip that Petal can do with a document. We have covered the first part of the transformation in the round trip in the previous diagram, so I'm not going to go over this first square on the left. So this is basically what I showed you. Now it gets, after uploading and parsing and creating the JData object in the LWData library has completed, we will have a full document tree that represents the original XData document as a JavaScript object and containing all of the original information about node names, contents, attributes, and child nodes. Sorry. Now, ProseMirror LWData will transform this object into a schema-compliant ProseMirror document and display it in the editor. This document can now be edited and modified in the Petal editor, and Petal will make sure that the editing process will comply with the LWData TD. So I think I have to go quickly over our challenges. And so we had to deal with TypeScript. Everybody, or Eunice and I, my colleague, were new to TypeScript, so we had to learn it. We had to deal with legacy code. We had to deal with outdated TypeScript libraries and dependencies, cover all this. And suddenly, we're also in the process of updating TypeScript. Challenged with deprecated methods that weren't supported anymore. So we had to deal with all this, and that was basically what we did in order to get the code working to implement our new feature. So at the moment, what we did is we separated the libraries, which was a monolith, into two packages so that they can be separately published, and we have an NPM package of ProseMirror LWData and the two LWData library packages. We have a documentation, so it's all covered. You can create a generate a TS doc documentation, and we have implemented the round trip of uploading a file into the editor, editing it, and downloading it back again as XData. And we are planning a GitHub integration so that what you can edit will be passed on to your GitHub repository as a commit. And we also want to have a source, an editor to view the source file, and also we would like to have a collaborative editing facility. Now I think I am going to not thank for this talk, but we'll show you, of course. So this is the editor. This is has changed in color, but has I quickly sit down so it's more possible. So what I would like to show you is we have the upload facility here, so you can upload files. I can quickly click on this, and it's no wonder it's the same file at the moment.
So, and it takes the file name, and there you have an HTML representation of the X data. And what you can do is, of course, you have these, like you probably know from WYSIWYG editors, these buttons where you can obviously create new elements, like a list. So we have a new list. And we could also, what I mentioned, this is the debug mode. So you see what is represented by this line. So we have the X data or the LW data paragraph. We have the body. We have the topic node, which is the entire document. We can display images so that they will nicely be transformed. And yes, it supports lists, all elements, and I can alter them also. So I have to quickly show you this, and we'll go back. I have a new list, and let's see what happens if I download this file. To see it, press and hold. Escape, OK. I think I have to, yes. So let's open it and see what happened. So this is the new file with my changes inside. There's the new list suddenly, and well, it's an ordered list. And to prove that I haven't prepared this, I'm going to show you the source code once. Oops, that's the wrong one. There it is. So that was the original file that we just saw in the editor, so I've made it quickly for the demonstration. So, whoops. Obviously, no list inside, so this is the start. And this is basically the round trip we are doing. So, and everything is open source. And if you like to contribute or have a look into this demo server, you can go to petal.evolvebinary.com and have a look yourself. So you're not doing the entire processing is done in your client, so it's done on your machine and your browser, basically. No server involved. And if you want to have a look at the repositories, we have links for LW data and prose mirrored LW data, and we would appreciate if you find anything, file an issue, or want to use it into your own project, you can do so. So thank you for listening, and I wonder if you have any questions.
Any question? Okay.
Thank you very much. I find this interesting, but I have two questions. So I'm going to ask the first one first because it doesn't have any baggage to it. Is how tied to the LW data scheme is Rose
Petal.
Prose mirror? That is to say, is it separate enough that it would be easy to swap in some other scheme? If I, instead of using Ditta, my authors wrote in JATS or whatever, DocBook.
If I understood you correctly, we pass, or we have, we pass the LW data, DDT, the schema in the library, so we already have these checks. The prose mirror schema is basically what we need to identify between the document node and what is marks. So this is to build up the editor. I don't know if I answered your question correctly. So we comply with the LW data, or the transformation complies with the schema. This is how the libraries are built. And what I didn't mention is that we, by the separation of the two packages of the AST, we comply, or we already handle the schema by, probably a wrong explanation. We cover handling X data files, and if we And we wanted to extend it also to handle H data, to handle M data. So that is basically what we cover with these packages and the AST.
I think I have that as an answer, but
then go ahead.
The second question is, I have to front load it by saying, I like this, I'm glad you did this,
Okay.
but I'm not sure why.
You're not sure why.
Because I think a lot of companies faced with this decision, if I understand your problem space correctly, would have said, okay, we'll buy Oxygen or some other toy, and let our people author in LW data, and then port it over and have a web interface.
But you mentioned it, so it's not open source, is it? You have to buy it. So we wanted really to have an open source tool.
Well, I mean, you don't have to buy Oxygen, you can use Emacs if you want.
Yes, okay.
like every good person, that's right.
We wanted to have the WYSIWYG option is not there, so we wanted to have a visual documentation for people, not to have an account, not to log in, whatever. So, I mean, just to have it on the in a web-based facility. So I don't know, we did some research and we couldn't find anything else. That's what we meant. We had this compromise of using an existing editor which is capable of customization, and for us it is a perfect tool. And of course it is in the beginning. As I said, the roadmap is long, we have a lot of ideas with it, and this is just the beginning.
Again, thank you.
Thank you.
Okay.
Thank you very much.
Thank you. Yes.
Our next speaker
Oh,
is going to bring you to the database world.
It's better if you take.
Yes. Okay. It's working.
Hello. Hello. Can you hear me? Is that fine? Is that working? Is that thing on? Yeah. Hello. This is. Let me see if that works. This is me. And wow, I have a problem. I can't see my speaker notes. Well, I'm a core developer of XSDB since 5 years. My name is Yuri Dino. I also go by this weird little thing there. It's a play on my last name, -O. And I have been consulting for Exist Solutions and Gintech for the last 7 years. I mean, Gintech is a newer company, so since its inception. And in that time, we have done a lot for one specific website, historystate.gov. And if you are as me and you are soaking information up like a sponge, you do look at the data you're handling and then think, what do they have on UFOs, right? And I looked it up. So I took my phone and put it in UFO, and to my surprise, I found an article about the Premier Minister of Grenada that visited in 1977 and spoke to then President Jimmy Carter and said something along the lines that, yeah, there were sightings of UFOs in Grenada and we should maybe look into that. Grenada, by the way, I fell deep into that rabbit hole. Grenada was then just 3 years independent, so this prime minister must have been the first prime minister of independent Grenada ever. And for some reason, they published that. If you don't believe me, this is a QR code to get to that article. So it is there. And there's more, by the way, if you search for UFOs on historystate.gov. And I noticed that because I saw search terms in the log files that
create the database about UFOs. So, but how did the data get there? Obviously, it's the meticulous work of all the historians working at the State Department and sifting through the tons of data, historical and new stuff, and but also it is in parts us. I'm standing here for a large group of people. Yeah, I'm not doing this alone at all. Even Alexandra did contribute to that, and I think a lot more people. I cannot mention them all. But what is being built is a publishing environment around XSDB or with XSDB. And yeah, I would like to read my notes. Maybe if I highlight them, yeah, it's better, at least. So as I said, XIST Solutions has supported the department since years. And what we especially like in the collaboration is that the State Department has a very strong stance on public data and open source. And so this is what we and the State Department stands for. I hope at least that I'm not saying something too wrong here. So my request from my phone got somewhere. How did it get there, right? And the clouds opened, and there was this database. HSG Shell, which is also open source, and you can run it on locally. So there's a possibility to run the entire website locally. It does depend, this is where the request comes first at. It does depend on XSDB, obviously, so it runs on that platform, but it also depends on two main libraries, HTML templating and TI Publisher Lib. TI Publisher Lib is part of the TI Publisher, the project started by eEdiciones, but it actually here predates even the naming of that project. So HistoryState.gov has used something even before it was named TI Publisher Lib, but they still continued to use it, and both of these libraries that I just named render data. So we also need data packages. This is what the front-end service consists of, basically. I'm just picking out the important parts for today, right? All of these, the application and the libraries and the data are all XAR packages. Who is familiar with XAR packages here? So there's obvious, yeah, even more. So that's, okay. XAR packages are a standard, and it's not only supported by XSDB, but also by BaseX, for instance. And it's the standard way to deploy software to an XMLDB. We make heavy use of it. Where do they come from? Where do those come from? From GitHub releases. So everything that we do, all of these packages are built on GitHub, and each build will create a XAR package as a result. These XAR packages then are used in a Docker container that contains all of the project, which we use for two things. We use them in the GitHub releases to test before we release, and we provide that Docker container to local development, which tremendously sped up the setup of those projects. It could be a day before, and now it's just like half an hour. Ed Porter was so nice to introduce you to the benefits of Docker, and I'm very glad that you did that. We love Docker for exactly that purpose, although we don't run the CI in Docker, but inside of GitHub natively, and we don't use an enterprise license. But if you want to look into the entire setup, as I said, it's open source. You can look it up and you can copy it to your needs. So we even went further, and those GitHub releases are being built whenever a commit goes into the main branch. And that is even raising the version number to the correct version number based on the commits, and that is done by semantic release. And we are using conventional commits, which you definitely should look up. It's a great tool to specify the format you want your commit messages to be written in. And it's very customizable. There's another tool in a separate system that is the annotator, which will then, in the end, provide new data that goes into some of the packages. That we are not there yet, but it's this is already in productive use, and that annotator is also part of the TEI publisher family, and allows you to add persons and names to tag persons and names and terms in a corpus of text. And it uses Spacy for that. So we send structured data to we transform structured data to text, send that to a model. It's here Spacy. This will likely change, and it's also written in a way that you have adapters for several different things. And that will then allow editors to, it will mark stuff in your corpus as potential names or potential places, mark those up, and then you can select with a custom authority. You can then, here they use custom authority that comes from Airtable. This is why it says Airtable. You can then say, okay, this is President Nixon that is talked about here, right? This name is President Nixon. And I can also show you, I think, there should be a slide below that, but there aren't. Okay, I will show that in the end. I have a slide where you can see how that looks like. The idea behind that is that it's a round trip. So when you have marked up 1,000 of those documents, then you can retrain your model to be better for the next 10,000. And as I said, Spacy is just one option you have. You can use any model that you want to train. Now I was only talking about how information got there, but actually, as I already said, we have several subsystems. There's actually a lot of servers. And now we need to get those servers somehow set up. They're all living in AWS for this project, definitely. We have also customers that run their own data centers, but here it's AWS. And to quickly set up new servers and also to be able to recover from disasters quickly, we chose Ansible to set up new servers. Ansible is just one, you know, there's tons of out there. I'm quite convinced that you use your own setup, but Ansible works for our purposes very fine. There is, in the XSDB project, there's XSDB Ansible as a role to be used to set up Ansible endpoints or Ansible instances. Note that we don't use Docker here. We are setting up bare bones servers. It does work for our needs. It does work better for our needs here, and Docker only for testing and local development, because that way we have more control over really what is happening on the server. And one thing I forgot to talk about here in Ansible is that where am I time-wise? Is that, okay. Updates should be idempotent. So when I run Ansible, set up a server X with a different role, set it up and run that same command again, it should do nothing. It should say everything is fine, right? So keep that in mind. This ExistDB Ansible role sets up ExistDB and configures it. So whenever a configuration change, I can run that same command again, and it will only change the configuration. And it also sets up packages and uses a new command line interface that was created, XST. What XST also does is allows us to automate installation processes of packages from several sources, like from the package registry that we have. There is a public repository in ExistDB, but we can also run a private version of that. Depends on your use case. Here we have a separate one running inside of the AWS cloud of HSG. You can install local files. Sometimes you need to have this weird little library that only is used in your specific use case, and you don't have another place to get it from. So a local file system is an option, but you can also use GitHub releases, and this is obviously what we make big use of, because we have now this automated pipeline to get updates whenever there is a new commit. Now we have a server, and we now have them set up. There's everything running already, but data is updated, right? Now it's a use case of publishing that data. We have a staging environment, and we have a production environment, and they need to be even updated separately, obviously, because you first want to see what is that okay, what I want to publish, before you put it into production. For that, we created Tuttle. Tuttle is a library that allows you to sync a collection with a Git repository. A collection inside of exist is then tied to that and knows which commit hash have I checked out, basically. So whenever data changes in that Git repository, we can run a command. And here is that slide I wanted to show. So I definitely want to show you the other one. Tuttle has sped up the publishing process by an order of magnitude, I would say. So there is specifically one package that's called FRUS, Foreign Relations of the United States of America. And FRUS is like 4 gigabytes of XML data, and publishing that every time when there was a typo fix is like crazy. So what we now do is we look at the remote hash and look at the local hash, and then look at the diff, look at all the Git commits that were done, and then figure out what we really need to update. So that went down, even if you're updating several files, it's like minute or under a minute. So before it was 20 minutes, right? So there's a big difference, because indexing is currently one big bottleneck in ExistDB that I have to admit. I can't like put it under the rug. So indexing as less files as possible is key here. This is the Tuttle API that is called. It's written in OpenAPI. It's an OpenAPI definition, and uses the Roaster library that was also published a while ago under the eEditiones umbrella. And yeah, it has several routes, and one is git incremental for a collection, and then it will do that. I'm not going to show that today. If anybody of you want to see any of those libraries specifically, please come to me. I don't have enough time to show them all. It's just impossible, I'm sorry. So if you have interesting data, as the Department of History has, then people come a lot. And now we're faced with the problem, okay, it was not just people, it was robots and even more. And they're constantly hammering your server. So we needed to come to a solution how to efficiently serve that website. Any XSDB instance I have seen in production runs behind a proxy. So we have Nginx here, and Nginx has a caching option. So we have the Nginx cache. That's the easy part, right? You just serve every page that was served, you put into the cache, but you will hit limits. And especially we'll have some routes that shouldn't be cached, right? Searches shouldn't be cached, at least not for long. And the State Department even said, no, we want every content page to be, if it changes, to be immediately changed. So we had to find a way to do that, and we found one. And that is that the application, HSC shell, has a cheap way of knowing, okay, has it been modified with the if modified since header. So that the not modified check becomes cheap. We can do that every time. And if 304 modified comes back from the app, we just serve the cached website. And that also allowed us to sleep well at night. So we, after introducing this caching strategy, all of a sudden, a lot of problems went away. And all those bots, they just hammer away, but we don't have a problem. So we are almost at the end. What I just showed you is a bunch of things that you can pick and choose from to build a stable and scalable publishing environment around XSDB. And I think the logo does show you this, this approach very well. Thank you for your time.
Thank you very much. We have plenty of time for a question.
Oh, was that fast? No. Exactly in time. At first. I have to admit.
Thank you very much. It's interesting to see what this Department of State historical is up to. It's always interesting. Mm-hmm. The concern that's floating through my head is not about any particular piece of this, but rather that, you know, the Department of State not only has an obligation to publish this stuff, but they have an obligation to be the keeper of records and make it publicly available here on out for all future generations, despite the fact that the leadership of the Department of State changes every 4 years, which might make it a little harder. I'm just wondering, there seem to be an awful lot of pieces here. Does that mean that there's more room for failure, and failure that you can't really control for very well? If one of these pieces doesn't survive an update to the operating system or something of the sort, are you in hot water?
Okay, at the heart of this is data that is encoded in TEI, as I said, TEI publisher, right? And this odd transformation that TEI publisher lib provides is something, so with your ODD file and a TEI file, you should be able to produce a useful output in 20, 30 years, because it's self-documenting. So not only the encoding is documented in that ODD file as well. So you can look at the TEI and have the specifics, but we even went so far as to move even more metadata into the TEI files, because that's the right place for them to live, instead of some weird place in a AWS bucket, where it was before, you know, and was scraped somewhere manually. So yeah, this is not the end of the road, don't get me wrong. There is much more, and we are continuously improving on that project, and we hope that we can do that in the future, right? If they choose to still work with us in the future. Yeah, I hope that answers your question.
Any other question?
So you mentioned that you use Docker in your testing. Can you speak to why Ansible was a better choice than using AWS and deploying Docker through K8s? You mentioned that it's more configurable, but in my experience, you can set up how much resources you request and all that good jazz with K8s and customize and whatnot.
Yeah. So the short answer is we had to go live. And a lot of that work was already done. And so we could build upon that and could actually have an improvement right now. The long answer is that Kubernetes is a whole set of new beasts that would require more resources to just do that. I hope, yeah, but we can continue that discussion. I'm not so familiar, I'm myself, I'm not so familiar with Kubernetes, but my colleague who is has said, let's not do this. And then he has a good reason for that, yeah.
Okay. One more question? Thank you very much again. And break for coffee, isn't it?
It is.
It is. Right.
Thank you very much. I will take the mic.
announcement for the sister conference. So
Okay.
The microphone to the issue because this way it will be moving and sketching. So yeah, this way should be better. And it's unmuted?
I think it's not. I think it's. You can hear.
Okay.
So, thank you very much. It's the last leg before the dinner and the demo jam. Without too much harassment, I arrived to a number of 6 or 7 people that accept to be part of the adventure. So there is few slots left. Yeah. So, and still time to come along and to give me your name for that. Okay? And we will have a few words for our sister conferences and some of them will happen very quickly in the near future. And first one is Balisage, and Norm will say a few words about that.
Is this thing on?
Yes.
Okay. Yes, so I will be brief. XML Prague is not the only excellent and exciting markup conference. There are a number of exciting conferences. I'm on the program committee for Balisage, which meets the first week of August. It's an entirely virtual online conference, so there's no travel to get there. We have talks on XML, both visible and invisible, JSON, graph query languages, overlapping markup structures. There's a whole range of things, and I don't have to read them all to you because the preliminary program is already online. So you can check that out at balisage.net. Tiny bit of bad news. The late breakings are due today. So get typing and this evening and get a late breaking in. We have a few slots left, and it's always fun to see what people are working on. So thank you very much, and see you at Balisage.
Thank you. So remember, balisage.net. Next is Declarative Amsterdam in November.
So this year's Declarative Amsterdam will be in the same place in Amsterdam, the 7th and 8th of November, both online and live, so you can turn up and be there. The call for papers is open, so please submit, and we are offering one free place for the winner of the demo jam this evening.
Thank you. And our sister conference that take from time to time our place in June, maybe next year.
Right, so hi, I'm Mari Nordström. My colleagues at Markup UK are there, Andrew and Geert. And next year we'll be doing this instead of XML Prague. They'll rest that year. Will happen... Oh, you get to speak, Jirka, so no worries. So will happen either in April or June. That depends on the venue, actually. So we're not decided that quite yet. But you can check markupuk.org. We should have that up, and well, hopefully soon. And also a bit closer by is the demo jam tonight, and we will also be offering a full pass to next year's Markup UK to a lucky person doing a demo. So thank you, and welcome next year.
Is the full pass for April or for June? You know, I ask silly question. Yeah, depends. Thank you very much. So, our next speaker will be presenting things about acronyms, very complicated acronyms, and he will tell us a lot of detail about that. Please, go ahead.
Thank you very much. My name is Fredrik Årström. I usually work as a consultant
long before I worked at Spotify and Oracle. Maybe 5-6 years ago, I accidentally stumbled upon a different way of visualizing XML because I had to read a lot of XML. Since the last couple of years, I've been turning this discovery into an actual language and a tool. So if you ask yourself, you are a new developer who is not very experienced in XML, you're going to pick a config file and you're going to use it for your new program. Will you use the top way of presenting your config file for your users, or will you use the bottom one? Unfortunately, the truth is that the new developer will definitely pick the bottom one. And I know that every one of you, since you are very experienced in XML, clearly see through the XML, just like Cypher did in the Matrix movie when he saw all the green stuff falling. So for you, this question is not quite relevant, but for most other people like me, mere mortals, we like the keyword storage. Unfortunately, config files always grow in complexity. So eventually you will need XML expressibility or something similar, but by then it's too late. So XML loses. So our first goal, can we assist a human, give him cognitive assistance while working with XML? Yes, we can. We can present stuff as key values, key equals value. And the rule is very simple. If an XML element only contains text nodes and entities, we can present it as a key value. This is a way to do data-oriented XML in the XMQ format. Now, there is no root node in this one. XMQ actually permits statements without root nodes. So you use a tool to re-add the root node, or you can write the root node directly into the XMQ file. When you load XML or XMQ from a config file, contrary to JSON and other languages that want to map from the language itself to a specific object model, XML does not need that, and neither does XMQ. You just query the data file. And I think this is rather interesting because if you look at the previous attempts to do similar things like F10ML, they were seduced by this aspect of presenting the data storage file as objects in a language. I don't think that's necessary. I only think it works for JavaScript. So in this way, you can query XMQ files in the same way as if it was XML files. But here is the real problem. Do you see it? There is a space, there is a tab, there is a new line. There is a wide ideographic white space. Okay. We have a problem in XML. The white space situation comes from the history of XML, where you started with a text file and you introduced markup. So given the original text file and then adding markup, you get a conflicting situation. Some of the markup will belong to XML, some of the markup will, white space will belong to the content. And in XMQ, what I've done is that I separated the white space clearly in separating white space and content white space. And then the content white space is what is getting sent to the application that reads the XML file. And that content white space, in turn, can be significant or insignificant. But that depends on a lot of factors. What application it is. Is it a browser? Then you have CSS files. So let's take a look at an XML. We got a ship order, and to you, it looks obvious. In XMQ, it looks like this. Okay, looks pretty simple. Here's a trick with the white space. The XMQ file will remove the incidental indentation. This is a trick that comes from Java text blocks, where the source code formatting will be removed, but you will still maintain new lines. So in this text node, that it will be inside the XML, you have 1, 2, 3, 4, 5 spaces, and you have 1, 2, 3 new lines. Here, you can visibly see that there is an extra new line at the end. You can see that we have one indentation and then two indentations. And this block here can be pretty. So here we have another example. XMQ makes it easy for you to see where the white space is. That is content white space. If you try to present this as XML, well, we have this problem. Can you make a new line before the pre? Yes, you can. Can you do anything inside the pre? Probably not, because it probably means pre-formatted. In the second case, you don't even know what you are allowed to do with the content inside the div class P, because it might be connected to a CSS file with white space preset, or it might not. So you're locked out. I consider this to be sort of a bug in XML, but it's fixed in XMQ by separating white space and content white space. If you do the opposite, that means that you remove all the separating white space. You get the compact form. The compact form is interesting because it created a symmetry, designed the language, which means that it flushed out a lot of bugs. So it's helped me solve a couple of things against comments. HTML and XML comments cannot handle new lines, but XMQ can. And of course, pretty printing is pretty size expensive, takes a lot of indentation. So it makes sense to have a compact form as well. Here's another example. We have HTML, and we have tried to pretty print this code. But you can see that after the S, we had to place the new line inside the element, because otherwise there would be a space. So there is a word, sleep, S-L-E-P. And if you don't do it like that, any new line pretty printing will introduce spaces in the output. In XMQ, it looks like this. So you can see clearly that there is no space between S and Li, and there is no space on you get to P. And there is a single space before the nabla. So we have a tool already. So let's demo. Here's a config XMQ, and this is also what it looks like textually. We can take a look at the ship order. This is XML. And we just type ship order XML. And you get it pretty printed with colors in your terminal. The tool is already available for you, downloadable as a binary for Linux, Mac OS, and Windows. If you want to, you can pick it up in your browser, and it will pre-render a HTML page, and you can read the source code to your XML as XMQ in the browser. If we take a look at this file, this is a WIPO patent file storing RNA sequences for COVID vaccine patents. It's clearly not markup. This is data storage. You can see that here. You see that inst qualifier, note, target, location. All of this is data storage. So it makes sense to take a look at it using XMQ. Here we want to page the XMQ within the terminal. We could bring it up in the browser. And you can see that, at least to me, it's more readable for data storage. It can also visualize HTML. So, if we take a web page, you can see the doc type, you can see HTML, you can see a lot of scripting. And the scripting just happens to have a little tabs in it. It's a lot of scripts. So we want to take a look at a cleaner HTML, where we delete using XPath all the script elements and the style elements. Now it's cleaner. And you can see that for something that in the old days was considered markup, you can see that we have a text node here, search slash dot, because all the text nodes are green, so you can easily see them. But in otherwise, it's not much text actually. So even HTML today is mostly data storage, that's storing data about the layout. Another interesting, we can take a look at an SVG file. Oh, the tool also handles dark backgrounds. So if we take a look at this, here we have an SVG file created with Inkscape in XMQ format. You can see that XMQ handles all the namespaces, which is rather interesting for SVG because we can see sort of a historical view of how the different tools evolved. So SVG is an image format. Sudipode is the first vector editor, free open source, that then was forked into Inkscape. So we have all these namespaces showing a historical history. And we can take a look at the, let's go back to the presentation. Something that you might already have seen when you see this XMQ, which is XML, 100% XML, is that it looks a little bit like JSON, doesn't it? But that was not the design goal. Was that I designed this language to work with XML. And then after the fact, I could see that there are similarities with JSON. So I wrote a JSON parser inside this tool. And the JSON parser was so similar to the XMQ that I could reuse the same callbacks that I used to build the DOM tree. The only thing that's needed is that you invoke a synthetic element name, because JSON objects does not have element names, so we insert an underscore instead, which is nice because the underscore is a valid element name in XML. And, well, you see there are only two more attributes needed. A signifies that this, if you want to turn it back into JSON, it will become an array that you can see here. And there is another attribute, S, which is used when something looks like a number, but you don't want it to be a number in JSON. Then you attribute it with S and say, yeah, this is going to be a string anyway. That's strange, isn't it? Two attributes and an underscore. And you have XML compatibility with JSON. So the XPath becomes simpler. You can do this, select, and you will understand where the underscore comes from. It's just an element. So I think Michael K. talked about this. Question about the object model, the data structure. Is this a unification? I don't know, but it's a different way to see JSON inside XML without having to have a completely separate data structure for JSON. And one very useful aspect of XMQ is when you write XSLT transforms. Because if you do not generate HTML or something like that, you have a problem where the indentation of the XSL transform source code will affect the output. So we have all sorts of settings here, method HTML, and other things like that. But if you don't use those in a proper way, there is a big risk that your source code in the transform will actually become part of the output. But all of that is solved by using XMQ, because in this case, there is actually no content white space, which you can see because there is no quotes. And in this particular case, this XSL transform works on use JSON. So we can see here that we can curl some REST API, get the JSON, have XMQ work on the JSON, transform it, and then output an HTML page. Let's see if I, yes. So where is the problem? Don't we need HTML somewhere? We do. And I use HTML for markup inside the tool. Because when I render the output, the XMQ output, I present it as text, and then I insert coloring information, start to stop. And that has to be compatible both for the terminal, HTML, and TeX. So in that situation, I thought, well, of course, I should use XMQ for my own output. But it turns out, no, for markup, HTML is better. So I do use HTML inside the tool. So simple question, it was an experiment, but all of this turned into a lot of answers. What is the meaning between key value storage versus markup? We know that XML can store both. And now we've seen it. We just use a different way of presenting the XML. And if it's relevant, it looks better in XMQ. Or if it's relevant data-oriented, and it will look better in XMQ. So we have realized that white space can be solved if we take care of separating and content white space. Shrink all the separating white space, suddenly we have a compact form. But compact is not strictly a goal by itself. It's nice, it helps the symmetry of the language. But if you really want to go compact, you should go to machine binary XML. And you don't need an XMQ binary form because you have XML binary form, because XMQ is XML. We have config files. I use it all the time to debug complicated HTML pages and stuff like that, where I want to see things in a more easy-to-see way. And I also mentioned in the beginning, why do we want, or why do some people want to try to create languages and map to object models directly? It doesn't make sense. I think data storage is independent of the object model of the language. So conclusions, XMQ is XML and HTML. You take control of the white space. It's better for human cognition. We have a surprisingly good mapping to JSON. There is tool support already. So you can go to this website, libxmq.org, and you can read about this tool. And you can find a link to the GitHub where the binaries exist for Linux, Mac, and Windows. And you can download them now and try it yourself if you want to. Thank you very much.
Thank you. We have a few minutes for a question. Oh.
Lovely, I really like it. Did you show any examples that I missed of mixed content?
What do you mean when we say mixed content?
I mean, marking up individual words or phrases within a paragraph.
I can do it like this. When I wrote my doc book for this conference, I wrote it in XMQ. Mm-hmm. So, this is what it looks like. We don't have mixed words here, but if we go down a bit, we have some quotes. Here, quote, tierceness is of minimal importance, and then citation. So this is what it will look like. And this is a border case, because this is actually sort of markup. But it looks okay, I think, in XMQ.
So when do you need quotes around the strings, and when don't you?
Very good. So the safe strings contain only no white space. So if we take a look at the ship order, you can see that ID equals numbers, but numbers doesn't mean anything. It's just text strings like XML. The point is that the number does not contain any white space. And it does not contain the reserved characters braces or parentheses or the quote sign. So such values can be presented as a value without quotes. If you have sailing equals the empty string, that's 2 quotes. Then we have a single quote because within the address there is no other quotes. But in the coordinate, we have triple quotes to quote single quotes inside it. And if you have double quotes, you have to have, or triple quotes inside, you have to have quadruple quotes. So you can quote any text string using enough quotes, and you can comment. I didn't have time to go into the comments, but the comments are similar, slash, 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 star, and then you can comment anything, including recursive comments, and then you end with slash, star, slash, slash, slash. So that's the trick. You use equal amounts of quotes. The thing is that it might look complicated, but when you look at the output, when you analyze existing XML, it looks pretty good. So sometimes in XSLT, you end with a single quote, but that's usually the code. So you can just add a space, and then you don't have the problem. Yep.
There was one question from YouTube coming, so I will try to read it. Is XMAQ similar to HACL, HashiCorp configuration language?
Sorry, which?
HashiCorp configuration language.
I don't know what that is, sorry.
Okay, so then it's hard to answer.
It's hard to, yeah.
So.
Thomas.
Hi, is there a grammar?
Yes, I got a handout, and it's actually in the article as well.
Yeah,
so anyone who wants a summary of today's talk can bring it here.
Thank you. No more questions? Thank you very much.
Thank you.
Thank you very much. Thanks.
Sasha.
Hey everyone. Thank you for a nice presentation of how we can change XML. So I took the challenge and I changed not XML but our dear XSLT. It happened that people not much outside of our world appreciate its syntax and capabilities, and developer experience is really I will be silent in this direction. So when people 2 years ago come to me, well, in our group, I'm part of the W3C Web Components member, and we've been asking for volunteers to pick up the declarative custom elements. The custom elements, that's the web components, the tags in HTML, which actually doing some stuff inside with the UI and the codings along with it. The only browser-supported fully functional templating engine is XSLT, but apparently nobody is using it. Question why? So I tried to look on it and taken the challenge. So now you will see the changes in XSLT syntax on development experience, and actually it goes way beyond of it, because the solution which I will be presenting, it's also the cybersecurity question. Custom element was implemented multiple times by folks. So far, I know only one implementation which actually fully functional, which has fully functional templating engine. It does have the business logic and the actions connected to the browser APIs and events.
It's currently open source library, published on the GitHub, NPM, and CDN. It is under consideration of proposal to be part of the HTML stack. And going further, I'm planning to make it a browser plugin, mobile and Internet of Things SDK, secure browser as the evolution towards the native platform by implementing by the, each browser, hopefully on the planet. What custom element can bring into the web as the application platform? The web has kind of well-known stages. There is a web 1.0, 2.0, but the third, I would not call the blockchain stack, but rather integration of multiple vendors on the same page. As now, you cannot find any page which does not have at least like dozen of different services from different vendors, and all of them working through the JavaScript without limits and borders. There is a conflict of interest between what they want to collect on you and want to hide. Some of them providing the authentication logic, so they want to protect you as much as possible. Others want to track every move, literally every mouse move on the screen. So obviously conflict of interest is there. Question, is it possible to make it happen without compromising the business for those companies? Well, declarative syntax, that would be the answer. Why declarative? Because if it's implemented in a way without JavaScript, with safeguards in mind, unlike the JavaScript originally, then we will have no such issues. With third-party application integration and general pattern, we will have the larger attacks of surface. The assemblage of applications contributed to the broadened attack surface with vulnerability of single became a risk for all. Security is common denominator, obviously. The level is as strong as the least secure component on a stack. As of now, there is no insulation between applications. JavaScript allows extensive uncontrolled access across applications, API, user data. So what if you need to provide a nice user interface for login flow, still keep other services like feedback, social media, analytics, and some pages without compromising the user input? The answer will be custom element. It's actually a runtime engine which allows to create a full-blown application. Nothing is shared between those sub-applications. The strict ownership matches the declarative custom elements, encapsulation, context owner can control the children elements, but none is leaked upwards. The business logic as a transformation rule resides in XSLT, which results only in generated content. The CSS styles are scoped also inside of DCE, so they will not break owner page and components. The presupposition is reimaging the development with declarative custom element as well. So the developer experience, in addition to the some benefits. Declarative syntax gives the low-code principles. So it eliminates the reliance on specialized JavaScript developers. In this case, the no-code principles driven by AI will be more straightforward. So I would expect that amount of the web applications created by non-programmer crowd will increase significantly. But in the same time, because of breaking the borders between different applications from different vendors, no security issue here, will create another boost and level of magnitude of reusing of different applications on the web. So who in general would benefit from such approach? Obviously, the high security audience. So I've seen here document management, procurement system, healthcare, you name it. So those definitely would, and I would prefer to talk to my bank using pages which have disabled JavaScript. So by default, I would know that there is no compromise here. We're talking about another layer of security safeguards. The applications which would need more integration with third-party, so those are content management systems, social networks, project management systems. Among of them, Google's sites, Adobe Experience Manager, Vercel, WordPress, Drupal, and any content management which perhaps some of you implemented as well. Social network sites, if you remember, many of them raised because of including third-party vendors applications like games and voting, follow-on up. So the Facebook, Twitter, from very beginning, they offered the integration of third-party applications. The only trick, how to make that safe and secure and not compromising your personal data. Well, in social media, there is nothing to compromise. It's broken already. But if we will, besides of the logic, include the safeguards around the user behavior, then it will be a different matter. But this declarative custom elements advantages are going way beyond. So what is the custom element? As I spoken before, it extends the web components, web standards. It would provide the micro front-end patterns for embedding third-party components. And key differentiator of custom elements is declarative syntax as for UI, as for the business logic. The key here is that application needs something to run on, so the business logic should be part of it. It also provides the data which can be changed in runtime, and the stack is it is introducing the new terminology for the data islands. Before it used to be the XML islands. Now I call it slices, which along with the slots which come with the web components will become a very powerful concept of working with the data in them. So it happens that security is not only about exposing something. It's also about ability to grab the network traffic, ability to steal the user interface pieces, especially on mobile. It's about how much CPU each vendor can take. And who've been working on XSLT engines, the parameters like how many threads are permitted to be run for particular process are there, how much memory and how deep the call stack should be, it's already there. But on the web platform, especially on JavaScript world, there is no such limits. So we able to introduce the platform which will be aware of those and create safeguards around the whole stack of the potential influence between different applications. It happened that proposed solution includes the full development lifecycle support. So that's what you see right now is implemented. There is way more to implement ahead, but what we have as of now is not a part of most of the libraries which I kind of worked with before. So it is a fully functional template. As mentioned, it's XSLT based. No limits there.
It allows to have modular development, which will give you the ability to create libraries and reuse them. It has the data access for the internal data associated with component. Obviously, the things of template, conditions, each variables, application features as of now not well in the full scope of browser API, but it does include a gentleman minimum to create the identification flow or form filling, which includes HTTP, storage, and events. The development support is also part of the equation. Without proper transparency into your data into transformation, you cannot troubleshoot what's going on with the code. So you need to have something which exposes your internal data. So I created the browser plugin transformation, which exposes the necessary data inside. So those includes the data, the XML, the XSLT, which allow you to use developer tools of your choice to do the debugging against each phase of the rendering. Pretty similar to what you have as of now in React, for example, when you're able to replicate things. The development support goes a little bit further. IDE does have a support for the new tags and in suggestions and validation of the code. You do not need to go to the XML or HTML. You're able to work with the normal HTML, and that's the primary key here. So the folks will not, who do in the web development will not go outside of their own zone of comfort. So of course, there are plans of doing things. How what will go further is not set. There is only very first step. So if you want to be engaged in the projects, that's a proper time of doing so. So we want to integrate with the declarative web application. As of now, you've seen just the components. We want to have the applications to be built this way, shared across multiple pages. Currently, CDN already is there, so we don't need to invent the wheel anymore. There are some things which is my company, SynchroFunct, is planning to do, so it will create the browser plugin, disable JavaScript, so it will become available for each user. It will have the SDK for mobile platforms and Internet of Things. And obviously, looking for the clients who will be willing to try the technology up. Well, there are some extra stuff. And, well, that's the things which is I'm planning to become alive. SynchroFunct AI, that's a little company of mine which want to cover the thing implementation. Now, to be more straightforward, I'd like to present you the live code, which, how we can switch it. All right. So folks had a doubt about the performance. So in here, you see the real time. You cannot notice actually the numbers below of mouse position changed and DOM update at all. The reason that local implementation is actually creating
div between the existing DOM and what has been generated, and only the changed part will be placed in will be in place. So it means if you have your own custom components or existing elements which required to be kind of preserved in place, we will be able to do stuff without modification, changing the component. One of the example is real-time typing. So as you see here, there is no delay, and the original component stays in place. So no selection will be lost, and input will be in place. Let's go to changes of the syntaxes. Folks from HTML world kind of see the XSLT prefix as the big showstopper. Okay, my apology. It looks like I need to go to the browser. Syntax. Browser supports only XSLT 1.0, so I had to extend it a little bit in order to understand the embedding of the XPath results inside of body itself. So curly brackets has been used as a denominator for the data selection, and the data selection is oops, wrong one. Over here. So you see the data DOM here is rendered as the multiple layers which will include the attributes which are passed to the declarative custom elements. Those are default entry for any XPath. The reason why default entry is attributes, because when you use an element, first thing which is HTML developer expects, that's going to its attributes, not to the data, but rather what has been passed, and that's immediately should be available. Then there are data set. I've been following the HTML standards and trying to reflect the data structure to match what browser internally is exposing. So if you have data-attributes, those will be named as a data set, and that's also part of the equation. Then we're talking about the updates of things. So if we will use kind of attributes and change them, the values will be immediately propagated to the content. Content will be rendered, and you will be able to see the result. The CSS also is available out of the box. So let me show you the CSS demonstration. It will be easier. So everything what is in the CSS style tag is scoped to the component, which means those styles will not infect not the page and other components. So you can go bizarre and use without any prefixes, which means it will be applied directly to the component itself. But you will be able to override it not only for your own component, but also for instances of those components. Let me see where I showing it. Perhaps bad idea. There are some changes to the XSLT, to the XPath. Some stuff like attributes usually needed default values, and those can be provided in here. So the slice local storage request.
over here. It happened that if you want to provide some value in case if it was not set, XPath has very kind of 1.0, which is implemented by the browsers, doesn't have proper syntax. So in this case, I extended the double question mark operator, which has been presented by our gurus today. And so in case if the proper selector does not exist, so in this case, I'm trying to find if the P3 was passed as an attribute, then it will use the value default P3 as such. This attribute is also useful for a few other cases as well, when you want to chain multiple values next to each other. The potential of use for the custom elements goes to the multiple different cases like okay, so that's now I'm going back to the styling. So in this case, you see that style is defined only for single component, but in here, it's defined on the custom element level, but applied for each instance. The slots, that's another thing which is not specific to XSLT. It's a part of HTML standard. So we have two different templating, how to say, principles. One is slots, and another one is slices. So data slices are a little bit different. As I mentioned, that's the structure of the DOM, but slice give us ability to associate the value of any component, in this case like input, and value will be propagated with a slice on txt. So if you will take a look on data DOM slice and then txt, it will be over there. You're able to define what event will be triggering the slice update. So usually for its form submit, or it's the change event. But if you want to have more responsive, it will be either key up or input. In this case, you will be able to track the changes as user type immediately. Okay. It happened that normal inclusion assumes that XSLT import will use another XSLT. It has been extended here to support another import data as a template. So I could import either SVG, HTML, or the data island inside of other resources. For example, if it's a library of SVGs, I could pinpoint to exact SVG, or this is library of another templates, another custom components. That would be the one. And in here, you see the example of extraction of the wave. That's the hand here. Well, custom logo or the mass.ml formula. All of them actually reside inside of external HTML file. And obviously, the external XSLT work as well. Okay. I did not show you the support on IDE level.
So let's go to the IntelliJ and see how it will work. So customer element obviously has own things here, but if you talk about the any of the XSLT tags, in this case it will be XSLT if or XSLT for each. That also will become a part of the documentation, even if it's inside of HTML. So it's not XML, it's not XHTML, but normal one. All right, we're running out of time. Thank you very much. Now the questions.
Thank you very much. Is there any question?
Hello. In one of the first slides, you showed a model to isolate the scope from other web components or custom elements, declarative custom elements. Is that will that probably be an impact on performance there? What do you think?
Interesting that with more capabilities, the performance of these components is better. And the reason, because we're using the native XSLT engine, unlike others who, for their template interpretation, have to use JavaScript.
Okay. Any other question? Sit.
So you may have to dumb down your answer a bit, because I have to admit, this went over my head. But the basic idea, as was asked before, is that a DCE, one of its capabilities is to separate concerns so that different third-party vendors wouldn't have access to each other's information, right?
Actually, it's opposite. It's a separation of the data between them. So the component, DCE component, has own data island, which is not overlapping with others. And only valid way of passing information in between is through the attributes on the DCE itself.
Okay, so that makes things make a little more sense in my little brain. Did you show any of those attributes? Did I miss that?
Yes, but I did not highlight their functionality as communication between the components.
Okay, I just missed that then.
So the slice is always associated with the value attribute or value property. So it could be string, then an attribute. It could be the object, then it will be property. And once any component has value changed, usually through the event, it will be propagated to data island under slice / and name of the slice with data inside.
But nowhere else. It just goes in there and it doesn't get propagated elsewhere.
No, it's only inside of its own instance.
So the instances don't have to be identified because it's only within the island that anything happens.
That's correct.
Okay.
So thank you very much again for this presentation.
Thank you. I cannot see it.
It's okay. Thank you. That's perfect. Maybe you can help me. Yeah, sure.
Next slide.
Our next and last speaker for the day will continue to bring us in the world of the web and has a very interesting question about CSS.
Yeah, thanks so much. Okay, this is going to be the usual problem solution story. In a way, I'll talk about layout designing with CSS, structure ideas from web and how they can be used for print, and how XSL and XPath might be part of a solution. I'm aware that this is an XML conference, and in the preparation of this talk, I thought that I may be digressing from the main topic here a little bit. But on the other hand, CSS is made to style XML documents, and I also promise to come back to XSL. My name is Anne Rudolph. I work as a style sheet developer for Docufy for about 7 years now. We and I use SCSS and XSL for our layout configuration tool, Docufy Layouter, where users without CSS knowledge can configure a layout. Docufy develops software for technical documentations, among other things. And we publish user manuals from our custom XML files that users write in our content management software, Cosima. And we transform it into our in-house exchange format, which we call Docufy XML or DY XML. And this is also the input format for the Docufy Layouter. And in this context, it is sufficient to say that DY XML is a restricted XHTML format, which is split up into some topic files that are referenced by a main file. So the content is basically HTML. And since XSLF is no longer developed and Antenna House has a CSS formatter for many years now, we just need to add some CSS. But we also needed XSL from the start because we had to produce one resolved XML file to generate PDF. And we also needed to add directories, chapter numbers, page area content, and so on. So Docufy Layouter in the end was only, in the beginning, was only able to publish PDF files. But over the years, we added 2 more HTML formats, one for our content delivery platform Topic Pilot, and the other one for a standalone HTML package. And thanks to CSS, this was comparatively easy. So just to show you what Layouter is about, we can configure different layouts, cover pages, multi-column layout, right-to-left layouts, responsive HTML. I can go on with thumb indexes, edge indexes, multilingual documents, and so on and so forth. But for this talk and for the issue here, I want to stick to safety and warning notices. They became highly configurable over the years because they're an important part of the documentation for technical writers. In DY XML, they consist of a signal word panel with a signal word and a safety alert symbol, a symbol panel for specific hazards, and of course the message itself. As the images are part of the safety standard, they are part of the DY XML and not of the layout. So for our first design, we copied our old XSLFO design. And we want to make it look like this. So nowadays, and with CSS, you could use, for example, grid to get this result. So for our initial projects, selectors were more or less like simple. They consisted of one attribute and maybe one element. So this leads to specificity for 10 or 11. So the 10th digit is the attribute and the 1st digit is the element. But as you can also see here, there are other risk levels and safety standards, and the hazard symbols might be optional. But so far, CSS is still somewhat organized, and as I said, we use SCSS, which is a precompile language that provides logical structures, mix-in, selector nesting, and so on. Which helps us organize the CSS. But, as you can imagine, we did not stick to one layout.
Next, we implemented the ANSI safety standard. On the same XML construct, it only differs in one attribute value. We added a more compact design for multi-column layout to save space. We also added some configurations like colors, borders, fonts, and such. But as safety standards are, or the standard does not define an actual visualization, and they are a sensible part of the manuals, customers tend to have numerous requirements for it. So this led to something we called arrangement variants, which is basically layout configuration, which we implemented with SCSS and some extra wrappers that we generated with XSL to just add some more positioning variants, also for ANSI, but it's a little bit more restricted there. Then there was some requirement that's called safety chapter. So it's a first chapter in a document that explains general hazards, and the safety notices there should be more reduced. So for ISO, we just skipped the background color. And for ANSI, it is more restricted. So we needed an extra arrangement variant there that's called embedded. And it also should be used within instructions. Then the next thing we added is right-to-left layout, for example, in Arabic. And we also have our HTML formats, so we needed some compact design for responsive layout as well. And in addition to all the visual stuff, there might also be some technical differences per consumer. For example, Antenna House only supported the grid layout recently, so all the arrangement variants for PDF had to be implemented with table layouts and floats. So what happens when we just look at, for example, the signal word panel? Selectors are multiplying by a lot. And we might also have some additional selectors for specific media queries. And they all refer to, for example, wrappers, RTL attributes, and different variants that are expressed by different attribute values. So we still have SCSS, which helps us organize the selectors, but all those selectors become more specific, which makes them also less predictable. And they may conflict with any additional requirement, and the specificity is increasing even much more. So what the problem is here is that specificity is implicit for CSS selectors. And at some point, they become barely scalable, and there's nothing like granular precedence as in XSL. So when we look at it from the perspective of the cascade, our current problem lies with specificity and order. And we have other parts of the cascade, for example, the importance, the shadow context, and the inline styles, but they are no sustainable alternative or are simply just not possible in the environment. Browsers started to support layouts for, I think 2 years before. It's a nice feature, but it does not really help us with our problem. But it's nice to keep it in mind, though. So what can we do? CSS originates from the web, so despite the differences between web and print, it is both user-driven and it is both CSS. So web CSS faced the question of large projects much earlier as it developed with the web. So let's take a look here. I put together some overview of developments that I found interesting for myself, but it's not a complete overview. Before anything else, of course, it started with good practices, like, for example, keep selectors as general as possible, be consistent, split up files, comment your code if you do anything fancy. But as the web evolved, there seems to be the necessity for more structure. So in 2008, Nicole Sullivan introduced her idea of object-oriented CSS. She talked about reusable visual patterns, about how structure should be separated from what she called the skin, but she focused more on the concept and on the actual realization. But based on her ideas, Yandex published a naming methodology, BEM, that stands for Block Element Modifier,
which offers a more concrete idea to keep specificity lower by adding one class per what you may call a pattern, and maybe one additional class for some modification of it. From 2011, it started with some architectural ideas. The first one was SMA CSS, which stands for Scalable Modular Architecture for CSS. It sorts CSS rules into some types, but those types are strongly inspired by the structure of websites, which makes them hard to adapt for print, really. And they do not offer a concrete concept for specificity. But parallel to this, there were some other developments, you might call them. Examples are Atomic CSS or CSS in JS. They abandon the specificity altogether by just adding one class per declaration, which means one property and explicit value. So to work with that, you really need a framework, and because with Layouter, the users can choose the values, it's simply not possible to implement it like that. So something like 10 years back, Harry Roberts introduced his idea of inverted triangle CSS. He proposed some very abstract levels which seemed promising for print or cross-media. And the levels or layers were also kind of linked to a specific, to a CSS specificity range, so to say. So let's have a deeper look into this. ITCSS, the basic concept are three axes. It's the reach, the specificity, and the explicitness, and they form a triangle which includes 7 levels or layers. It also, which is very nice, it also considers SCSS, maybe because it became more prominent in the CSS community over the years. But if you read about this ITCSS, there are different versions of it, depending on whether CSS or SCSS is included. So I picked the version that was most useful for me. So the first level is about global SCSS variables. Then next comes some functions and mix-ins. The third level is the first level that actually results in CSS. It may include some wildcard selectors or general add rules, also, for example, the add page rule. Then the next level are the basic HTML element rules. And if you need, I read different things about it, but if you need, you can also implement the object level. Some talk about it as general layouts, for example, like grid or flex, which you use over and over again. Some also say it should be like small repeating parts of a layout. It really depends on the use case, I think. So the next level is about components, which is the reusable visual patterns, like, for example, a sidebar, or in means of print, it could also be a directory entry or a page header. And the last level are utilities or trumps, which are very specific rules to override all the preceding rules if needed. And the nice thing is that components and objects include the naming methodology BEM. So when you look at it, for example, you take the directory entry, it consists of the elements enumeration, label, leader, and page number, and it might have a modifier, for example, table of content level 1. So this is nice because it keeps the specificity very low, and even though you have a lot of styling. But all the web concepts assume that the layout comes first and that the content is added. The layout may even decide what content is displayed, but this is not how manuals or publications are working. Here, the content is usually first, and most of the layout adapts to it. So you don't want to have a table of content in a publication which only consists of one chapter. So
let's take a step back and let's think about it from the start. We have DY.XML, and we want all those beautiful safety notices on the same XML construct. We may give them even names. We may call them hint, ISO, normal, maybe with a variant reduced and danger, hint, ANSI, normal, or embedded. Maybe with the descendants, hint, ANSI, normal panel, with the variant of color danger, and so on and so forth. Whatever we can define for the looks. So on a more abstract level, we have the semantics on one hand, like the danger safety notice, and we want to get to some visual patterns, maybe also to some variants, if necessary. And with this separation, like semantics and looks, the styling is scalable again. So what we need, of course, we also given them some nice names. What we need is some kind of mapping or linking in between. And this linking should depend on an XML context. It should also depend on layout configurations and on the output type. So you might have guessed it already, but what better to use than XSL, since it's already there. And it really leads to a classic XSL template, which adds, for example, class values, but could also add any other attributes that are useful for your linking. And it could also, of course, add additional elements. Linking everything, of course, takes effort, but it plays on the strength on both CSS and XPath, because XPath is there for selecting elements. It is also more granular than CSS selectors, and it can take the following axes into account. And CSS is left only with specificity and styling. So when you look at the long CSS selectors from the start, they become predictable again and have a limited number of variants with a low specificity. Some selectors might even be obsolete because they were only there to override other selectors in some kind of specificity war. But you may also notice that we kept the direction attribute at the ancestor because this is actually generated by an SCSS mixed int and is consistent over the whole style sheet, which also makes it predictable. So looking back at how requirements increased, with Docufile Layouter, we started with about 100 layout configuration and 1 output. Nowadays, we have kind of more than 1,000 layout configurations and 3 outputs. And some configurations are more complex than others, and it is a still growing project. So for safety notices, they started as something that could easily be selected with selectors. At the next stage, so to say, they will still be selectable, but tend to be more specific. What is important to notice is that visual patterns existed from the start, but because one visual pattern was one semantic element, it was less obvious. So the next stage, by adding attributes, this is the only way to select the element, because CSS selectors are no longer enough. And on the last part, even that becomes hard to maintain. Because what's actually happening is that visual patterns are increasing, even if you don't link them, they're just there. And other semantic constructs might be, of the same project, might be in different stages, like for example, the tables might have different attributes, but they are already there and can still be selected. Or inline elements are usually less complex, so they can easily be selected. And you just have to believe me on this one. Figures with legends have additional elements and also additional attributes for all the positioning we're doing with it. So for a certain size, pure CSS solution is really possible, and SCSS can aid with that. Maybe if you want, you can even add cascade layers with ITCSS if it helps your structure. But as soon as selectors become more specific, XPath offers more possibilities and help to keep CSS simple. So what's the moral of this story?
adding some CSS isn't enough for large and growing projects, because with complex requirements, selectors display XML semantics. And the higher the specificity, the less scalable it all becomes. So XPath, if it's possible in the environment, can handle selection of elements much better, and by adding an attribute to link between semantics and styling, it is really good to read as well. And it can also be like any attribute. So the remaining challenge, I think, is left is a comprehensible labeling of all the visual patterns. Maybe also the choice of the notation. For example, BEM provides some double minus to visualize the modifier. What it also might conflict with XML comments here. I'm open for suggestions if you have any. And what is untouched by all the structure approach is the challenge of the cross-media support for CSS features. And maybe one final thought, why did we not think about this from the start? There were more requirements than initially expected, like the usual stuff. We had little experience with large SCSS or CSS projects. And most of all, and maybe on a more philosophical level, we thought more in semantic categories rather than in visual ones, and did not consciously differentiate between those two. That's about it. If you're interested in the topic, you can look up some of my sources. And thank you so much. And if you have any questions, I'm happy to answer.
Thank you very much, Anna. Very, very interesting. Any question? Oh, yes.
Welcome to Semantic Theming. As the one who actually been doing similar stuff, I really kind of understand the challenges you faced. But from the other side, I see that you have a lot of advantages through the going as a XSLT as a part of the process. Have you met the academic publishing on the subject of semantic theming?
I don't think so.
Have you done research on that?
Probably not.
Okay, thank you.
All the people asking questions that are above, please raise your hand so I can make some sports.
Thank you for the presentation. I didn't quite get what exactly the XSLT did, but what I understood is that it actually increases specificity. Is that a good understanding, or am I mistaken?
The XSL is like the linking between the CSS and the element by adding a class. So I'm not sure whether I get your question.
Well, I thought the effect of that is to increase specificity.
Not to increase it, to lower it. The CSS specificity.
Yes. Okay. I would have to read the paper, I think.
Yes. Is there any question? But I've been pleased to see the contains token function being used, because it has been added like 10 years ago into the XPath language, especially to support selection of classes in HTML.
Yes, it was supposed to do. No question? Okay. Thank you very much then.
Thanks.
Thank you. So it's a wrap up for today, and we join you in a few hours, exactly at 7, starting 7. Okay, it's 1 hour, so you can go by walk and be there 5 minutes late. It's okay. Okay, we will wait for you. We will wait for you. Yeah, yeah, it's there.
3 passes.
Yeah, and 3 passes the same day at conference in April and June, if I understand correctly. And so it's in 1 hour, and yes, so it's a new adventure. See you there. Give that to me.